Okay, so good morning, everyone. Assalamu alaikum. Welcome to this 132nd edition of the Zak World of Façades conference series. My name is Ahmed. I'm part of the organizing team here. I'd like to kick off the event due to the paucity of time. Let's start. Those who join us later can join. So, as I mentioned, this is the 132nd edition of the Zak World of Façades conference series. This is our third one in Jeddah. We had the first one in 2018 last year, and now this is the third one. Finished 3 editions in Riyadh and many more in the Middle East. So if you see, we're spread all across the globe, right from New Zealand up until Canada. We've got events in multiple continents. Facades are designed, engineered, installed differently in different places. So we are very blessed to have encountered different ways how they've been executed, and we try to bring ideas from one region to another region and vice versa. And this is how it's been very interesting for us to keep this event going with new speakers talking on new topics. Today's speakers also are from Saudi Arabia, from the Middle East, from Europe, who are talking on different topics, their experiences here in the Middle East, from other parts of the world. So hopefully you'll find today's agenda interesting. I'd like to thank our event partners, without whom this event wouldn't have been possible. I'll start off with our presenting partner, Alumil. Alumil is a Greek manufacturer of aluminum door, window, curtain wall systems, one of the leading players in this field globally. Our associate partners, starting off with Cox Global and Mantech, along with their Saudi Arabian representative Masa Equipment Company. So they've got building maintenance unit and facade access solutions. Ductal is a French company. Now I think it's part of Wholesome. They have UHPC, ultra high performance concrete. It's a product which is used bridges and infrastructure projects, but now they have engineered it to buildings, especially for cladding, roof and other stuff. EOT, German manufacturer. They've got fixing solutions, fasteners, rain screen cladding systems, and many more stuff. Future glazing, so they've got architectural glass, fire-rated partitions, value-added glass, lot many more products from the UAE, and now with a local presence in Saudi. A Proctor Group is from the UK. They've got breather membranes, vapor barriers, which are used for weatherproofing of your envelopes. Pyrobil by AGC is the fire-rated division of AGC. They've got fire-rated glass, as the name says, and they're also represented by their co-company AGC Chemicals, which is their solution to make ETFE and other coating products. QMAA is the Middle East authority for Qualicoat. Those would have heard of Qualicoat. Qualicoat is the standard for coating on aluminum, stainless steel, and other architectural applications. So QMEA is a Quali Middle East Association, the Middle East authority of Qualicoat for certifying coating. Saudi Rockwool, again, a Saudi-based company into mineral wool insulation for insulating, for protecting your facades from fire and thermal protection. Seale, German contractor, specialists in complex glazing solutions, structural glass, and a lot many more things. Technoform is a German manufacturer, thermal performance solutions in the form of polyamide and warm edge spacer bars. So they are our associate partner also from many years. Technoform are one of our earliest partners, have been asked to mention this. Vitro Architectural Glass from the US, coated glass manufacturer, and they've got a good presence here in the Middle East, represented by Khaled Raslan, their local rep in the region. So these are our associate partners for the event. We've got 3 sessions today. So we've got a mixture of architects, consultants, contractors, and we end the day with a panel discussion. They all are on different topics, and they are all curated for this local market. So hopefully you'll enjoy today's event. We've also recorded today's event, so those who have allowed us permission to share their recording with you, we'll give you the YouTube link a week from now, where you can watch this recording. And we're not taking any questions due to paucity of time. So the speakers will be in the breaks. You can interact with them in the networking breaks, and you can ask any questions you have. So that's it from me. Before I move on to my the first speaker, I'd like to introduce my colleague, Amro Hassan. He's going to be hosting today's event, and he will be taking you through until the end of the day. Thank you.
Good morning, everyone. It's a pleasure to be here in your beautiful city. In fact, I was born here 3 decades ago. I haven't been here in 15 years, but when I came back, the city changed immensely. I don't recognize it anymore. I don't know if I prefer the old or the new, but it's definitely beautiful. I don't know the next decade, what will the next decade bring, because Saudi Vision 2030 is just revolutionizing the landscape. However, all the giga projects and mega developments, the masterminds of these projects, some of them are within our lineup of speakers, some of them are in this room as delegates, and all the product manufacturers are definitely facilitating this, and without them, our masterminds could not push the barrier of architecture and design. Some rules, as Ahad said, there is no Q&A, so if you'd like to engage with our speakers, please meet them at the networking breaks. If you'd like to engage with our exhibitors, please meet them at the booth and learn more about their products. For architects, if you'd like to sign up for continued learning with the AIA, please make sure to come at the end of the day at the registration booth and sign up with your name. And now, enough of me, because no one wants to see me here. I would like to introduce the first speaker from the stellar lineup we have today. From the powerhouse architecture company hailing from Kuwait, I'd like to introduce from PACE, our first speaker of the day, Mr. Tarek Shuaib. Please give him a warm applause.
Thank you, Amro. Thank you. Good morning, and thank you all very much for coming so early to my presentation. I don't think there's a place for this. Just a little bit about myself. My name is Tarek Shuaib. I am an architect. I've been working at PACE for quite a while now. And let me see if we can work this. We're very lucky to celebrate 55 years this year, and we've been able to work with a lot of great partners in many countries. Our main 3 offices are Kuwait, KSA, and Bahrain. And we do some development funding work in different regions, which you see across the globe there. As I mentioned, we're very lucky to work on a great number of projects, like the avenues in Kuwait, and now we're working on avenues in Riyadh, and we've been lucky to have won many awards in those last 55 years. But today I was going to talk a little bit more about our historical approach and the approach that we've learned from the different international partners, our own designers, and how does that perhaps give a legacy for our architectural design in terms of identity for a modern Middle Eastern city that's developed, you know, from 50s until now, and where should we go? And I'll show you a couple of case studies at the end, which describe perhaps whether we've done that journey correctly. I was very lucky enough to sit on a jury for an architectural competition about 10, 15 years ago. And I was having this discussion about identity with the then editor of the Architectural Record, Robert Ivy, and explaining to him in the Middle East we have a lot of evolving languages and architecture with different architects from all around the globe. And obviously, it's an ongoing discussion, but it's something that we have to really be cognizant of. And what he really explained very simply to me is that historically, our identity of our cities was really around our climate and really based around the way that we communicated and talked and our cultural aspects. But we really had a heavy influence from the way that our environment affected our buildings. And therefore, how does that translate going forward? So I'm just going to go through a little bit of our legacy projects as well to perhaps explain that and how materiality kind of evolved across time, and then how does that influence going forwards. Obviously, with all this, keep in mind, we have a lot of energy requirements that are becoming more and more stringent. So one of the first projects, 1974, we were lucky enough to work with the Architects Collaborative, a partnership where Walter Gropius was a senior partner in there. And this was perhaps the first project that we used cast in situ concrete. If you notice, very small windows. In fact, a lot of people complained working in the offices to this day that they don't have a lot of daylight in there. some Jordanian stone on there. What's funny is to see in our archives, we get notes, we have telexes where they're sending from the Architects Collaborative in Boston, do this, do that, do that. So where we've come and where we've been, it's quite interesting that how design, now we send actual models across the world. It's really interesting how people have developed across a long time. This is perhaps our first project in 1968, and this was an architect called Rifat Tajarji. He's an Iraqi architect. He recently passed away at the age of 93. The use of arches, covered courtyards, covered walkways. It's a commercial complex at the front with residential apartments. The use of local sand lime brick as well was really prevalent then. Another piece of work with the Architects Collaborative where you see really kind of a stark outer wall with then, if you look inside, facing north, is the northern glass facade wall. But again, deep punched windows on the side facing south. And the background you see, I'll show this project later on, is Central Bank of Kuwait, which kind of references that, and that we worked on with HOK London. So this evolving language is prevalent in our work as well. I talked about earlier the use of cast in situ concrete. Here we started to evolve into an office building with precast panels, reflecting the palm fronds, and this was completed, I believe, in 1978, 1979. This is a really unique building. Now, this is designed by SOM New York. It's a United Gulf Bank in Manama, Bahrain. We worked on the supervision, the structure, and the engineering. Really, to this day, it still is a great-looking building. The way that they've used the brise-soleil in concrete, precast panels as well, and then the glass fins, and these beautiful punctured windows. And then when you get to the top floor, you look out to the northern facade, there's this triple-story atrium. This has an AIA gold medal, and you still see the plaque when you go walk to see the project. I walked through this building about just before Corona. It still looks great. It's a good building to visit, I think, and just wander around. A building that was completed about 92, 93 is the Arab Organization headquarters. This is a building that houses all the various organizations like the Arab Fund, OAPEC, etc. Why I wanted to talk about this building, while the materialities perhaps from Italy in terms of granite, etc., but the articulation of the windows seems to have worked with our previous jobs, and each elevation has a different aperture for each square window. So this southwest facade, you'll notice that the slanting of the windows is quite prevalent, while when you go to the other side, on the right-hand side, the windows are bigger and they prevent, obviously, they access more daylight. At the time, this was the biggest glass Pilkington facade wall, and this is definitely well worth a visit if you ever do come to Kuwait, because what they've done in this project, they've collected different artisans from all over the Arab world, and different rooms are done by different craftsmen. We have the largest mashrabiyya with not a single nail in it, manufactured in Cairo, and then we have perhaps a Tunisian room. There's also some Moroccan handicraft work, craftsmanship. It's really spectacular. So let's move our approach forward. I just wanted to discuss what has the past influenced in some of our more recent projects. So you go into early 2000s, and we're working on a very commercial project for Salhir Real Estate. The one on the right-hand side is completed in 2003, and that's a commercial office building, a hotel, etc. And you still note the very square punched windows next to that. The client then approached Fentress Architects in Denver, Colorado, to design this very slim tower on a very small floor plate. And they still kind of took parts of our language from the back facade, but also increased requirements, better light from better technology in glass, increased daylight requirements by users of buildings, made it more challenging in terms of cooling loads, etc. Moving forward, this actually received an award as well. This is designed by HOK London. We worked on the structural engineering and the supervision and many other mechanical aspects of the building. Very strong building from the backside. It has this austere shear wall on both sides, but actually when you open up to the north, it is a diagrid system with no columns on the floors except these diagrid walls you see, diagrid columns you see capturing the floor plates on the outside. This cantilever on the right-hand side is a 20-meter cantilever, which is the conference room for all the banking requirements they have. Again, you see we've worked on a lot of retail, so with retail projects it's quite difficult how to express the facade. This building was designed by PLP in London. We worked on the facade with them and articulated it in order to be a little bit more expressive. The function of these bottom few floors is just shopping, really, and it's the first vertical mall that we worked on, 7 stories. It's quite interesting to see. It was actually fully leased out by 91% at opening, which is really great for any leasable project like a shopping mall. In the background, there's a glass tower, which is about to be completed this year, end of this year. So as we go to newer projects like the IBECE, this is under construction right now. This is a banking studies institute, how to be able to have vision but protect from the sun. It was something challenging, especially in the location in downtown Kuwait. And a really centerpiece project for the new campus in Shadadiya. So this project continued our association and legacy work with SOM New York, and it's a series of function buildings which are related to the administration, library, and the core convention hall for the new campus. It's a series of these collection of buildings have their own function inside them, but then each building is covered by this lattice mashrabiya. We're very fortunate to get Farah Bahbahani, who's a Kuwaiti artist, to work with us on this and worked with SOM on these patterns. She actually exhibited here last year in the Jeddah Biennale. So each mashrabiya had its own language. Some were geometric, some were based on poetry, rather Khalil Gibran, or I think one Arabic proverb here. If you ask me to read it, I'm not sure whether I'll be able to read it, but it was really interesting to get to work with local talent on an architecture project with international companies. So just the 2 sort of main case studies we've been working on lately. It's an adaptive reuse is our first project. On the left is the pre-renovation project. The client came to us, same client that actually we worked with on Salhia, how to reimagine a project that they had had since 1978. It was quite difficult to replace it within the city, how to avoid too much destruction of the building. At the end of the day, we were just trying to give them a new, fresher look. How the main elements that we moved away from the canopy, replacing the similar windows, just improving and updating the skybox. There was a lot of aluminium and a lot of leakage problems. They had this very thin aluminium profile. The glass was from Switzerland in 1970s, gold-covered glass, which looked amazing, but still had to have some update to it. So we broke down these few elements. Basically, the box, we had unitized square panels coming just to fit into this slots where the hotel rooms were. And then for the canopy, the ground floor, we have our detail that we had to, because of the retail base was changed, it used to be hotel and restaurants, we now have a Dior shop and Tiffany and this new Basha coffee shop. We had to have larger spaces, more open, and the retailers wanted to use the 2 floors. So we had to change the canopy. Skybox on the top was quite an interesting challenge because we had an additional slab to come and take this skybox at the top. This is just about complete now, and I'm hoping to visit very soon. So that's the 2 renderings, and this drop-off here just opened recently so that they can access their the new retail entrance to Salahiyya Mall. So a lot of time we also look at the way we've developed our facades and the way that the energy is planned within a whole campus, and this is a really whole project. I could spend 20 minutes talking about it, but I'm not going to talk about it this except to show you some of the facade that we worked on here. It's a huge 1,200 bed hospital with a dental clinic, car parking, etc., built in a record 3 years. That kind of took a lot out of everybody at the office, but it was really great to work with such a great team. At the end of the day, all the patient wings were actually in these 4 modules sticking out, and the parts that are articulate, these are GRC panels, where it faces southwest, they're a little bit more pronounced, and then where it's the patient rooms, and they're in these little enclaves, let's say, are a little bit less pronounced. This is under construction now, some work how we're protecting the windows on a new tower for a client downtown. This is the clinic building, which is just about complete now, and I think you could see that. Again, the visual connection that I mentioned earlier in IBECE, it's really important how we've extracted now the different louvers on this, and I believe there's a drawing of the louver shapes, and we were trying to see how the modulation was working. And actually, we've done all the daylight studies as well that are associated with it. Then working with our team how to actually get the different layering, and the proportions are very important. So the bottom part is a car park, so we have to try and make sure the facade reads the same all across, from top to bottom. The client has now moved ahead, as I said, with construction, but we haven't decided yet on the louver colors, and I'm sure that's going to be a very big dialogue with them. We're hoping to maintain our design intent on this. Each tier has a different, little bit different articulation, and each tier behind it also has a different function. While parts are car park, parts are functional for the admin at the bottom. At the top, there's also some training. So I'm sure that a lot of you have seen that we have some new GCC energy codes upcoming. Different countries, I think, are addressing this. What is this? What is the impact for us that I've seen recently on some of our projects? We've had to introduce triple glazing to replace double glazing. We've been compelled to, replace to have argon and a lot more facades in the fill between. There's a lot of other glass coating in order to improve the thermal performance, meaning darker projects, darker glass. Thicker insulation of walls. So I think this is something we're all going to come to and be using a lot more. So just to come back again to see how a project that has just finished phase 1, and how did we manage to, or did not manage to, actually get some historical input from our old project into something that's now ready for occupation. We're just waiting for the electric cable to be switched on, the full power to come on. So in the downtown, very center of Kuwait, we have the new Palace of Justice courthouse. That's in the background is the Kuwait National Museum, and then behind us is the Kuwait National Parliament, and on the right is Sif Palace. It's a very civic area, and then to the north, the Gulf. This project has 142 court rooms, as well as 3,000 employees. And its composition is in two phases, and we've completed phase 1 alone, and I'll show you, but this is showing the project as a totality. So the premise of this project was to have a harder outside wall that's kind of symbolizing the stability of the court judicial system, while having also a layer of transparency so people understand that the judicial system is also quite transparent and nothing is hidden or swept under the table, etc. And with that, we reinterpreted our facades based on this kind of initial concept. We have an internal plaza which is modulated between the phase 1 and phase 2, so you get to look at the civic buildings to the right, and then to the left you get to see the downtown behind you. This internal part is what we call the geode structure, and I'll explain a little bit more about that. And then between these two, let's say, slivers is all the cores and vertical transportation which takes you through the building. So the main corridors to the courts, this is the initial rendering. This is a recent photo which was taken about 3 months ago. This outside structure is a fully unitized system. I'm going to describe it to you shortly. And these are the main corridors that access the courtrooms. So on the outside, it was a series of modules which are 120. So because the building as you go up is divided into different functions behind it, we had to have a flexible system that either you have a courtroom behind it, or you have offices behind it, or you could have the Supreme Council for Justice meeting rooms behind it. So there always has to be some kind of flexibility within this module. And the team developed a 120 module where they're able to have the different look and feel of what we were trying to express on the travertine outer wall. Always, sometimes it's glass and travertine, sometimes it's full panels of glass. And so this standard module was established because we also needed to be able to, as usual, everything needs to be done as fast as possible. We wanted to make sure the contractor was able to produce these items as easily as possible. So different details regarding the stone facade and how that was put together. I'm sorry that's not so clear. So the components, I mentioned the travertine, and then we have these what we call the hexagonal unitized glass. And these components all have different, I think there were 6 types at the end, in order to make this hexagon or geode-shaped facade. This facade also happens to be the skylight and the intermediate between the two buildings. And again, this was modulated in such a way to reflect the same type of geode structure. And the way that we designed it is to maximize the amount of light within the main reception area. And so at the end of the day, we've now finished phase 1. This is under construction. And this is complete. The next phase is to get rid of the old building and then, or jump over the old building and connect to the new one. I'm not sure whether we were successful to kind of restoring some of our legacy and history, but the project was being able to be completed, while we had Corona, etc. And I think because we used a lot of modularity, and whether it was the unitized geode system, and also whether we able to kind of make sure that the contractor was able to build and procure materials during a difficult time was quite a challenge. And we'd always welcome you to come and visit anytime you want. And so that's kind of a full circle of where we've reached. Thank you very much for your time and attention, and I appreciate you being here. Thank you. Thank you.
Thank you very much, Mr. Tarek. Our next speaker is one of the best minds to explain to you anything related to glass in the region. Please, without further ado, welcome on stage Mr. Khaled Raslan from Vitro Architectural Glass.
Okay, assalamu alaikum wa rahmatullah. Sabah al-khair. My presentation, yeah, I did it in English before in Dubai, but this time I'm going to do it in Arabic. الحقيقة اللي خلاني أحضر المحاضرة دي إن أنا كنت في أحد دول الخليج وكنت أشعر بالجوع، وفي حد نصحني بمطعم لازم أعبر الناحية التانية في جسر، والجسر طبعا كان معمول من الزجاج عشان طبعا أشوف الشواطئ والمناظر الحلوة من بره وأنا معدي الجسر. فاللي حصل وأنا ماشي في الجسر ببص على انعكاس بتاع صورتي، فأول مرة شفت نفسي نحيف جدا رفيع جدا. بعدين مشيت متر كده لقيت نفسي الانعكاس بتاعي بقيت تخين قوي. بعدين مشيت شويه لقيت نفسي بالشقلوب رجليا فوق وراسي تحت. استغربت جدا يعني كيف تم اعتماد هذا الزجاج، والحقيقه صناعه الزجاج واجهت تحديات كبيره لانشاء معيار قياسي بصري لتشوه او للزجاج البصري. قبل ما ابتدي في المحاضره احب اتشكر بعض الناس، منهم السيد هيثم الخطيب مدير جوتمن حاليا في PPP، سيد باسكول دي سيلفا مدير الفني لشركه GGI، ومديري طبعا السيد جلان ديفيس، ومديره المواصفات في امريكا مس انيسا فليكنجر. هنبتدي دلوقتي المحاضره، هنوريكم اللي هي النماذج او النموذج الجيد اللي هو ما فيهوش اي تشوه بصري، وشويه مشاريع من حوالين العالم متصممه. المشروع ده حقيقه في جنوب كوريا. المصمم هو شركه ايشين المعماريه، والتنفيذ شركه جيسون جلاس، دي من اهم شركات الجلاس بروسيسورز في كوريا. الحقيقه المشروع زي ما انتم شايفين فيه في اشكال فريده من الزجاج، وفي 3 الوان من الزجاج، ومفيش اي تشوه بصري. وده بنك طبعا اهم بنك في كوريا، بنك بوسان. هنا جامعه جنوب فلوريدا، دي جامعه على مساحه 6.3 كيلومتر مربع، وزي ما انتم شايفين الازاز في منه ازرق وفي منه اخضر مع اللوئي الكوتنج، وشايفين انعكاس السماء واضح جدا على المبنى. المبنى ده في مدينه مكسيكو، مجمع ماناكار. الحقيقه المبنى ده مميز لانه هو حصل على الجائزه الذهبيه ليد اللي هي رياده في مجال الطاقه والتصميم البيئي. الازاز في المشروع ده كله فيجن جلاس، يعني ازاز مرئي، مفيش سباندرل جلاس. يعني ايه سباندرل جلاس؟ يعني مفيش ازاز بيخبي عواميد او حاجه، كله فيجن جلاس، وبالرغم من ذلك مفيش اي تشوه بصري في هذا المبنى. المصمم كان شركه يودور، شركه مكسيكيه، تيودور جونزاليس. المبنى ده الحقيقه مبنى فريد من نوعه في مدينه بيتسبرغ في امريكا. هو من تصميم شركه جانسلر الامريكيه، وتنفيذ بور هابلد، وتنفيذ شركه ترمستاليزا، والمقاول شركه بور هابلد. المبنى ده مميز لانه الزجاج فيه يتنفس حتى يمنع التشوه البصري، بمعنى فيه فالف. هي شركه ايطاليه بس انا مش هتكلم عليها عشان لما كده نعمل ايه، بتحط زي صمام او منفاخ، فبحيث انه في فتره الصيف لما الضغط بره بيبقى واطي بتسحب هواء من الفاصل الهوائي بتاع العازل، زجاج العازل، وفي الشتاء بتعمل العكس، بتنفخ هواء عشان دايما ما بيكونش فيه تشوه بصري في الزجاج. المبنى ده في مدينة ألبرتا في كندا، والمصمم هو شركة فاسترز اند بارتنرز from the UK. دلوقتي هنشوف الأمثلة السيئة، وطبعا منع للإحراج مش هنقول أسماء المشاريع ولا مكانها فين، بس هتشوفوا دلوقتي الأمثلة للتشوه البصري. زي ما انتم شايفين في تمويج، المبنى ده برضو هنا شايفين التمويج والزجزاجنج في الزجاج. مثال آخر هنا برضو تشوه الصورة تماما، هنا طبعا يعني قمة التشوه البصري. فموضوعنا النهارده هو ما هو التشوه البصري، وما هو الذي يسبب التشوه البصري، وكيف نخفف أو نقلل من التشوه البصري. الحقيقة الأشعة الشمسية أو الضوء الشمسي بيرحل من الشمس إلى الأرض مسافة 9.3 مليون ميل، تقريبا 15 مليون كيلومتر، وبيسقط ويمشي في خطوط متوازية لبعضها ويسقط على الزجاج. لما بيسقط على الزجاج في بعض الأشعة بتنعكس من الزجاج، وبعض الأشعة بتمر خلال الزجاج، والبعض الآخر يستوعبها الزجاج، يعني بيمتصها الزجاج. الحقيقة هنا في نظرية زاوية السقوط، زاوية سقوط الأشعة بتساوي زاوية الانعكاس. فلو كان الضوء جاي، خط الضوء الموج جاي بطريقة عمودية، هينعكس بطريقة عمودية برضو. لكن طبعا إذا جاي منحني زي ما انتم شايفين هنا في رقم 2 و3 و4، إذا جاي بانحناء هينعكس بزاوية برضو نفس الزاوية بس في الاتجاه الآخر في نفس الزاوية. طبعا احنا بنتكلم في الحالة دي في وجود لوح زجاج واحد بس. فلما نروح لمكان لوحين زجاج الموضوع بيتعقد شوية. بيحصل ايه؟ احنا قلنا في بعض الأشعة بتمر من خلال الزجاج. الأشعة اللي بتمر من خلال الزجاج بتنكسر فجأة بزاوية أصغر من زاوية الانعكاس، وبعدين بتضرب في الزجاجة الثانية وبتنعكس بزاوية النظرية الأولى بتساوي الزاوية الأولانية. فهنا بيحصل ايه؟ ازدواجية. يعني بيبقى عندك، عشان كده انت لما بتكون قاعد في المكتب بالليل او في الجيم او في بيتك وعندك ازاز ده، بتشوف صورتك، الصورة الأصلية والصورة الثانوية، صورتين، وده السبب. طبعا في حالة إذا كان الإزاز كونكيف أو زجاج مقعر، فهنا الأشعة برضو نفس الحكاية، الأشعة بتنعكس نفس الحاجة بس بتنعكس لجوه، وأنت هنا بتبان أنت أو الشيء بيبان نحيف. بينما في حالة الكونفكس زجاج المحدب الأشعة بتنعكس لبره، فأنت الشخص أو الشيء بيبان سمين. طبعا هنا دلوقتي هنتكلم عن العوامل الطبيعية اللي هي بتسبب تشوه الإزاز. أول حاجة الارتفاع. إذا تم تصنيع الزجاج في مصنع وتركب في حتة 600 متر أعلى من مصنع، بيحصل هنا فرق الضغط. هو موضوع الضغط ده مهم جدا، يعني في ضغط داخل الفاصل الهوائي بتاع الزجاج العازل. إذا كان الضغط الخارجي مختلف فهيحصل حاجة من الاثنين، يا إما سطح الزجاج هينحني للداخل لو كان الضغط بره أعلى، أو هينحني للخارج لو كان الضغط اللي جوه أعلى أقوى. فطبعا دي ليها حلول، هنتكلم في وقت لاحق على الحلول للقصة دي. طبعا تغير الحرارة فترة الصيف، لما بيكون الجو حر الضغط بره واطي، الضغط جوه الفاصل الهوائي بيدفع سطح الزجاج للخارج، فبينحني الزجاج للخارج وبيعمل تشوه بصري. نفس الحكايه الضغط البارومتري. احنا عندنا موضوع الطياره، اذا حضراتكم لاحظتوا وانتوا راكبين الطياره دلوقتي، ازاز الطياره مش ازاز، هو معمول من الاكريليك بس بيبقى فيه ثقب بتشوفه تحت كده. الثقب ده هو فكرته معادله الضغط داخل الزجاج، عشان لا سمح الله ما ينفجرش يعني هي حاجه بسيطه جدا بس عشان الزجاج ما يحصلش فيه حاجه. فهو الثقب ده بيفرق وبيعادل الضغط داخل الفاصل الهوائي. ايضا احمال الرياح، يعني بالذات العمارات بتكون عاليه، الرياح بتيجي بتحمل حمل ايجابي على سطح الزجاج، فبينحني الزجاج للداخل. طبعا في مسموح وفي معيار مسموح تقريبا 22 مللي الازاز بيندفع للداخل. وبعدين نفس الرياح دي اللي هي ضربة سطح الزجاج بتلف من ورا المبنى وبتعمل قوة شفط بتشفط الازاز لبره، فبيحصل انه في الواجهه السطح الزجاج انحدر للداخل، وفي من الجناب بتشوف سطح الزجاج طلع للخارج. وطبعا استعمال اجهزه التكييف والتدفئه كمان بتخلي الضغط مختلف بين داخل المبنى وخارج المبنى، وكل ده بيأثر على الفاصل الهوائي والزجاج وبيحصل نوع من التشوه. هنا هنتكلم بقى عن العامل البشري بعد ما اتكلمنا على العوامل الطبيعيه. موضوع معالجه الحراره، طبعا معالجه الحراره هي بتقويه الازاز اللي هي بنسميها هيت سترينثنينج، وتقصيه الزجاج اللي هي الجلاس تمبرينج. والازاز طبعا كمان بيحصل فيه اثناء التركيب بينتني الازاز، كمان بيعمل تشوه بصري. وشركه فيترو عامه بتوصي بانشاء نموذج كامل في ظروف الموقع باستخدام نفس المعدات ونفس العمليات اللي هي تحكمت على التشوه البصري، عشان لما يحصل بعدين ما يحصلش يبقى في اختلاف بين النموذج والمبنى لما يخلص. هنا بقى قلب عملية الزجاج اللي هي الفرن. الحقيقة تنتج بكرات السيراميك التي تنقل الزجاج عبر الفرن بتنتج عن فجوات على الزجاج بيسموها رولر ويفز. عشان دي بقى هنا اسرار المهنه، عشان يتجنب البروسيسور او اللي بيدير الفرن موضوع الامواج دي عشان الشخص ما يشوفهاش، بيحط الزجاج بالعرض بحيث انه عرض الزجاج يكون موازي لبكرات السيراميك. بالشكل ده لما يتحط الزجاج بالعرض على المبنى، الشخص اللي ماشي الى جانب المبنى ما بياخدش باله من التمويج ده خفيف، لكن طبعا اذا شخص قرب على المبنى هيشوف شويه تمويج. دي احد اسرار المهنه لتخفيف التشوه البصري. طبعا عمليه التركيب اطارات الزجاج الحقيقه فيها تفاوت متاصل وعدم دقه في التركيب في انشائها، ولما يجي يتركب لازم الزجاج يكون متساوي مع بعض. لو كان الزجاج مش متساوي هيحصل تشوه بصري. وبالاضافه العامل او الشخص اللي هو بيركب ممكن يدفع من الطرف الزجاج بيعملها عمليه كمان بتعمل تشوه بصري للزجاج، لان الازاز بينتني او بينحني من الاطراف. هي دي الاسباب اللي بتسبب التشوه او الذي يسبب التشويه. نوع الفرن المستخدم، طبعا في انواع فرن مختلفه، الاشخاص المتحكمون في عمليه التقصيه، عدد الطبقات لطلاء الفضه اللي هي اللو اي دبل سيلفر، سماكه الزجاج، مستوى انبعاث اللي هو اللو الاميسيفيتي بتاع الزجاج، ابعاد وشكل الزجاج. شكل الزجاج بيفرق في التشوه البصري في عمليه التسخين. تبريد الزجاج او اللي هو كوينشنج، جلاس كوينشنج، والعوامل البيئيه اللي احنا اتكلمنا فيها. انواع الافران هنا هنتكلم على طبعا انا ممكن اعمل محاضره كامله على الافران، فهنتكلم بس على 3 انواع. هو بشكل عام عشان التحكم في التشوه البصري يفضل تسخين الزجاج ببطء مش مره واحده يعني. فلذلك هنا الفرن الثاني، الفرن الاولاني فيه غرفه واحده، الفرن الثاني فيه غرفتين. طبعا هيكون اغلى، هتدفعوا فلوس اكتر، بس التسخين هيبقى اطول، ففي تحكم اكتر على سطح الزجاج. هنا انا بفتكر مثل واحد، مراتي لما بتعمل لنا كيكه في البيت بلاحظ انه الكيكه نافشه من حته بسبب انه الكيكه منفوشه، انه توزيع الحراره على سطح الكيكه ما كانش متساوي. انا غالبا هنام على الكنبه النهارده انا عارف، بس يعني الفرن بقى التحتاني ده افضل فرن، هو الفرن اللي هو بالحراره بالتسخين الهوائي. هنا مفيش تلامس ما بين الزجاج سطح الزجاج وبكرات السيراميك، فده احسن حاجه وطبعا اغلى حاجه اللي هو الكونفكشن. موضوع اتكلمنا في تقويه الزجاج وتقصيه الزجاج. الحقيقه الاثنين انت بتسخن الزجاج لدرجه حراره توصل 700 واكتر، لكن في تقصيه الزجاج في تقويه الزجاج الهيت سترينثنينج بتبرده ببطء، فلما يتبرد ببطء الزجاج بيصبح مره او مرتين اقوى من الاصل، والضغط على سطح الزجاج بيبقى تقريبا 3500 ل 7000 رطل في البوصه. لكن في عمليه تقصيه الزجاج اللي هي التمبرنج بيحصل تبريد بسرعه، فالازاز بيقوى اكتر. طبعا بيعملوا كده عشان لما ينكسر بقطعه صغيره، بس ده بيعمل ايه؟ بيقوي الزجاج 4 و5 مرات، وسطح الزجاج بيبقى عليه ضغط تقريبا 10000 بوصه رطل في البوصه. هنا ازاي بيعرفوا درجه التشوه؟ طبعا هنا في اللي هو لوح الزبرة. فانت بتشوف لما بيطلع الازاز بتشوف انعكاس اللوح على خطوط الزبرة، ودي بتقول لك حاجتين. بتقول لك اللي هي الفجوات اللي اتكلمنا عليها من البكرات، بيشوفوا قد ايه ومسموح، وبيشوف كمان اللي هي التقويس او القوس الاجمالي للوح كله. المسموح في القوس الاجمالي في حاله اذا كان الزجاج غير مطلي 3 مللي، اما اذا كان الزجاج مطلي يعني عليه له اي بيبقى عندك 5 مللي مسموح. في حاله الفجوات او الرولر ويفز مسموح 0.3 للغير مطلي و0.5 للمطلي. طبعا في ادوات وانظمه معقده اكتر ومتقدمه اكتر وبتعطيك اللي هي زي الجلاستون ايلوك والاوسبري، بتدي مش بس التشوه، بتدي التسطيح والمقاس والسماكه والطلاء. هنا هنتكلم ايه كيف نخفف او نقلل التشوه البصري. اتكلمنا على اول حاجه التنفيس زي المثل بتاع الطياره. فانت بتحط ثقب في الفاصل الزجاجي، ولما قبل ما تركبه بتشيل الصمام ده وبتحط بيوتايل مكانه عشان يحافظ على الضغط داخل الفاصل الهوائي. استخدام وحدات زجاجيه عازله مستطيله الشكل. اكتشفوا انه الشكل المستطيل افضل من المربع او المثلث او المدور. استخدام سمكات مختلفه وجعل السماكه الكبيره بره والسماكه النحيفه في الداخل، دي كمان بتقلل. في حاله اذا كان الزجاج تريبل جليز يفضل يكون في ثقب في النص زي موضوع الطياره برضه عشان يحافظ او يعادل الضغط. اخر حاجه استخدام زجاج لديه نسبه اضاءه عاليه فوق ال 50% ونسبه انعكاس اقل من 11%. بالنسبه لعمليه التسخين، العمل بادنى زي ما قلنا اوطى درجه حراره ممكنه، واستخدام سرعه انتقال بسرعه خارج الفرن لما بيطلع، والاحتفاظ بصيانه الفرن طبعا، وتكون عمليه التقويه الحراريه زي ما قلنا احسن من عمليه انا هخلص على طول. طبعا هنا المطلوب من صناعه الزجاج عشان نخلص من موضوع التشوه البصري او يعني نخففه ونقلله، مطلوب استخدام احجام مختلفه، تغيير رموز القياسيه، نظام توحيد جديد. في الدبل جليز لازم نلاقي طريقه جديده نعمل فيها الدبل جليز وطريقه جديده لتركيب الزجاج. الحقيقه شركه فيترو عندنا السولار بان يتميز بانه نسبه الاضاءه عاليه ونسبه الانعكاس واطيه، فعندنا تحكم كبير على التشوه البصري، وعندنا مشاريع كتير جدا في المنطقه. انا ما عنديش صور بتاعتها، بس عندنا مطار دبي ازاز فيترو، مطار الملكه عليا في الاردن ازاز فيترو، في عندنا مشاريع كتير في السعوديه في الرياض مع مصنع سعودي امريكي، عندنا مول مصر، مول اوف ايجيبت في مصر، عندنا في ابو ظبي مشروع القناه، كليفلاند هوسبيتال في ابو ظبي، في الكويت عندنا مشاريع كتير للدوله، وممكن تيجوا عندي في الستاند تشوفوها. اخر حاجه دي هي بالنسبه للتشوه البصري، لا توجد صيغه رياضيه، لابد من التدخل البشري. تلعب القوى الطبيعيه باستمرار دور كبير، والذكاء الاصطناعي لا يكفي، لابد من التدخل البشري. شكرا والسلام عليكم.
شكرا Mr. Khaled. Mr. Khaled is an absolute encyclopedia on glass, and if you don't go visit him at the booth at the next break and learn more, you'd lose out, especially for the non-Arab speakers. Our next speaker came from very far away to speak to you guys today. He came from Paris, City of Lights, and he is a leader in facade design and engineering there. Please welcome on stage from VSA, Mr. Robert Jan van Santen.
Assalamu alaikum. Is the micro is working? Assalamu alaikum. My name is Robert Jan. I will, unlike the precedent speaker, I will do it in English. Sorry for that. I'm an architect, facade consultant. I'm Dutch. I grew up in Tunisia, so I was familiar with the Arabic language long time ago, but it was long time ago, sorry, so I do it in English. Our job is designing, engineering, developing facades, and it is something that has to do with construction and with architecture. So we are based in France, we are based in China, in Korea. We have recently been awarded by international awards by the CTBUH 2 times. Both projects are in China, by the way. And we are a company that is doing design and development research. Doing that, in fact, all our projects aim to develop unique solutions, not only for architecture and for aesthetics. In fact, most of our unique solutions are related to questions. And when we start a project, the first thing we have to do is to question the people, question the client, question the architect, question the market, question the climate, question the environment. And it's because of questions and the different ways to select different questions and then to find the answers that every building is so specific. In our work, we work on buildings and big facades. If you want more information, I have a brochure here. We have something like 600 projects built around the world. So I wanted to highlight 3 different topics that are little minor aspects, but I feel interesting aspects in our work. The first one, I went too fast. First one is the Hublot. It's a product. It's our smallest project, so to say. We just developed a window for many reasons. In fact, the window is a traditional element of architecture that has not been changed so much during the centuries. You probably feel that many windows, they are too big, they are interfering with the view. Also, they are a weak point in terms of performance. The water leakage is coming from there, air tightness, safety. So the traditional window is, I feel, something that we could challenge. So we challenged it in Korea, and we developed this Hublot. So when you look at the way how the history of aluminum frames, maybe there are some suppliers here, they all know gradually the projects, the aluminum frames were very simple. That was maybe 20, 30, 40 years ago. And gradually it becomes more sophisticated. Also with the thermal spacer of Technoform. I know they are here. Have a look at their products. They can really make very performing products, but the price is high. The final result is that when you get higher performance, you have more sophisticated products, and the prices are higher, and there's not always an architectural benefit also in it. So our challenge was, let's make a window without frame. And that starting point was the introduction to a project. I make it a little short. So we could make a window without frame, but then the question is, how can you open it? So again, the window that I can open was a challenge. And we found out that the most simple way to do it is just to make a hole in the glass. You can have a very big glass and you make holes in the glass and that is your window. And we made some analysis of ventilation with the university in Korea. And in fact, when you have 2 such openings, it's far enough for ventilation. And I think in this climate, you even don't look for ventilation so much. But even in more northern climates, more colder climates, it really makes sense to have reduced openings. So it goes a little fast, but basically we make a hole in the glass, we put a small frame, we put a filter for the dust, we put a cover for making the air tightness, and then we have a cover on top of the cover to make the interior architecture. So this is the way how it was designed at the beginning. Something you open by hand, very easy. For the ventilation, you see the traditional windows have some constraints with the U-blow. There can be some advantages. How to use it? You turn it, you open it, and you put it underside, and you have the air filter for the dust that you can clean very, very easily. Something that is very important, I felt, is that as architects and facade designers, most of the time the exterior appearance is the most important. And actually, personally, I feel the interior is even more important. And I was in Saudi Arabia 1 year ago, and I visited a very nice place, luxury interior architecture, and the windows were just aluminum frames with glass, with a handle, with hinges. Wow, I felt that such a beautiful interior is not matching with the poor quality of the window. And the idea came also on other projects that the interior appearance of the facade and of the window is something that is really important, and we must pay attention to it. So, because we take away the frame, we just have the window. So we develop different covers that can match different functions. You can put fish in it if there's not direct sunlight, otherwise they will die. You can put plants, well, many different things. Here are some examples. They are installed. So it is just a convenient solution. And mainly the only thing I can, in fact, really say is that you can challenge ideas that are there for 200, 300 years. You can challenge them because the world is changing. This one is also very good in terms of low carbon. It's very good in terms of energy. There are plenty of reasons today to challenge the traditional products. Brise Soleil, this is a project with Morphosis in Morocco. The whole building is protected by solar shading, and there is just traditional glass facade in behind. What is the main reason for Brise Soleil is to block the solar radiation and to have glass that can be clear glass. The previous speaker showed how can you adapt the glass to different solar exposure when there is no Brise Soleil. But if you have a Brise Soleil, you can actually have much more freedom in choosing your glass. The Brise Soleil is something that blocks. This is when you type on Google, what is Brise Soleil? You get this image, gives you an idea. The traditional ways of doing solar shading can be a screen that is a kind of filter, so it's a kind of compromise solution. The mobile blinds are quite efficient, but lifespan of a motor is around 5 years. And so there's a lot of maintenance, and I think in a place where there's a lot of dust, it's also mobile elements are not the most recommended ones. Fixed horizontal or vertical louvers, we already saw the previous speaker also mentioning it. Exterior louvers can be extremely efficient, but they can also actually be wrong. Maybe I show it here. When you have the light that comes on the Brise Soleil, on the louver, it will create shadow under, but it will reflect to the inside. So the Brise Soleil is less efficient than what you can expect, because it is creating the shadow, but it creates more energy in the other part. So it's a kind of balance. I can tell a short story about it. when you have a glass handrail and on the top you have an aluminium profile, or you have a steel profile, stainless steel profile. And you might think both are the same. In fact, the aluminium profile will be more comfortable for the handrail because it heats up less. The steel profile will heat up. When you do the louvers here with aluminium, the aluminium will not heat up because it transfers all the heat to the inside. If this one was in stainless steel, the stainless steel absorbs the heat and only the light is reflected. So there are a lot of misunderstandings about brise-soleil, I feel. And something that we try to develop, maybe this is maybe not specific Jeddah or Saudi Arabia oriented, but we try to have louvers that protect when you want to protect and that do not protect when you don't want to protect. So there's a kind of balance to do that, and to do it, if possible, at low cost with fixed elements. And this is a kind of solutions that we are looking for, and you are probably looking for with Vision 2030. So this is about reflection, I already mentioned. When you have solar shading, there are at least six parameters that influence. The latitude is very important. The orientation of the facade is very important. On the east facade, southwest, north facade, it's all different. And when it is different, the answers should also be different. If you see a facade where all the facades are the same, you can be sure that it's not efficient. It's probably efficient for one orientation. The rest is compromised for matching the same. It's not that efficient. The inclination of the facade is, of course, very important. The depth and the spacing between the louvers are important. You can incline the louvers this way. You can also incline the louvers in this way, and you will see that is a quite important aspect. And then the reflectance of the upper and underside are also very important. We have developed a tool that can evaluate for every solar shading its performance. It's creating a kind of identity card of the solar protection. When the sun can pass through, it is a red color. When the sun cannot pass through, it is a blue color. And this shows the performance of the solar shading. This point is when I look face to my facade. The upper part, when the sun comes here, the lower part when the sun comes from the ground, usually it doesn't happen, and the sun comes from the left and from the right. And for every solar orientation, I calculate the performance. And once I know the performance of the solar shading, I can put on it the sun path in summer, in winter, whenever, and I can get the solar protection, how efficient it is. And what we are trying to do, when you see the solar, it's very high, it is not, there's no solar protection, it's not efficient. And when it is here, it is more efficient. That means, in this case, when this is in winter, the sun is low, so the horizontal solar shadings are not working so well, but in summer, they are working better. Latitude is very important. This is in the north of Norway, and when you go gradually to the south, the sun path is changing, and for that reason, some solution that can be good in one area cannot be good in other areas. You must adapt. The same with the orientation, the same solar shading. You will see the result next here. When you are looking to the west, the sun is different than to the south and to the east. So the performance will be different. Again, when you have different facade orientation, you should design your solar shading in a different way. Here you can see very little difference between south and southwest. Already the difference in the results are quite important. So if you are looking again with Vision 2030, where we try to make low carbon, energy efficient buildings, this type of small difference actually is important because you can just double your heat gain because you have your solar protection, which is not optimized. Here you can see how we work when we optimize. In fact, when you have the orientation, your latitude, you have all the parameters. We try to see step by step how we can find the best solution. And you see here, from here to here, we turn the solar shading this way. Here we turn it the other way. There we make it black. And every time the result is different. And here you see the results. You look at the curve here, which is the curve in summer. Here it is going like this. In that side it is there. That means that just by changing the orientations and the design of the solar shading, you can get a solar shading which is up to 10 times more efficient. And that's for free. And I mean, if you have a solar shading, just design it a good way. Here are some buildings that really use the idea of solar shading accordingly to that principle, because you have seen horizontal is working only on the south, vertical is only working on the north, and all in between, if you really want to optimize, the inclination is actually quite the most efficient. So it is unexpected, but if you are looking for efficient solar shading, this is the direction you can go. And this diagonal, you can make it very small so that it doesn't impact your architecture, or you can make it very big and then it will impact your architecture. Okay, there are some other researchers, maybe time is too short to talk about it, but solar shading is a topic that can be, you can make a lot of design based on solar shading if you are just fixing yourself some constraints or some ambition. Always from the interior point of view, I feel. This is an example that we did for a project actually in Stuttgart, but that's a coincidence, for skylights. I think in places like here, like in Hong Kong, the sun is very often very high. So the skylight, protecting the skylights is even more important. I go very quickly. We do the analysis. We do a double analysis actually, and the intuition would be to put them in the other direction, but we think that this direction is more efficient. But to take benefit of the light and not creating shadow, I go fast, huh? But you can ask questions later, please. And here, in this one, you find again the logic that you had before. So it is not, what we did before was not wrong, but there's just ways to optimize it in a better way. And that is our engineering capacity, or maybe also not our interest. Okay, this is, we did two competitions in Saudi Arabia. This was a competition in Riyadh, but we did another one in Jeddah. We lost, unfortunately. But it was the opportunity to think at the window, not in a point of view from the outside. The outside was really not our main point. We were thinking, how is the window from inside? And I think the Moucharabieh, it is nice from outside, but it is completely designed for the people inside. So designing the Moucharabieh, or trying to find some qualities there, we found interesting to keep them, but design it, integrate it in a more modern way, especially the Moucharabieh that sticks out was a problem with sand. When you have a sandstorm, it might be a problem. I don't know how it is solved actually, but on our buildings where we try to reduce maintenance, you must avoid horizontal surfaces that can get dust and it can get dirty. So we just pushed the mouche à rabier on the inside and we started excavating in the wall. Okay, it is a just simple design. The result you can see from the inside. It can be nice. There is a kind of filter that you put in front or that you don't put, can depends. And you have the view to the side, you have the view down. I feel it is quite interesting to live in. Some speaker mentioned the small windows in the traditional architecture, and I think that's nice. But if the small window can only see in front of you, it's probably not the best. If it can see to the side and down, I think it's kind of thing that can be appropriate. And this was the view from the exterior. Personally, I like when I see traditional architecture. And actually, this hotel, you have seen the windows; they are quite well designed. Adding some decoration, it's okay. It is not for a function here; it is purely decoration. And this is a second design for another part of the project, where we just use the requirement of solar protection to say we move the window in the back and we create inclined surfaces. What is the interest of it? The first one, from the inside and from the outside, the window looks the same. If I put some decoration on the facade, most of the time when you are inside, you cannot see it. And with this type of window, there's a kind of inside-outside that I like personally. When you are inside, you see the part that is in the back. That means that is here. And when you are outside, you see the reveal that is here. It is just playing with the thickness of the wall. And again, it's playing with the possibilities to create reasonable architecture. That means we try to find reasons when we do architecture. We have worked with Zadid, we have worked with many architects that do very expressive facades with very strong design, and that's probably what the client was looking for. But my personal feeling is that our work should be more reasonable. And if we are reasonable, we can convince, we can explain, and it can be a long-term benefit for the people. While when you have just a design, after 5 minutes, design is over. Okay, thank you very much. If you have questions, please call me. I'm here really to engage discussions with you. We hope we can contribute to some projects here. So I'm here the whole day. Tomorrow I'm in Riyadh. So don't hesitate to call me. Thank you.
Thank you, Mr. Van Santen. For our next speaker and the last speaker before the break, I know all of you want coffee right now, but I really need you to focus on this one and keep it together. Mr. Jeff Dibdin from A. Proctor Group, please welcome him on stage.
So my name is Jeff Dibdin. I am the International Account Manager for the Proctor Group, who are a small company based out of Scotland. And just to begin with, just want to acknowledge the Zak World of Façades facilities that they provide. Certainly for a small Scottish company to be able to go around the world and present and meet people from different areas is a great resource for us to use. We've been active in the Middle East now for about 10 years, but this is actually our first time in Saudi Arabia. And I have to say that Jeddah is a magnificent city, and the conversations that we've had today already have been very encouraging. What we're going to talk about today is construction membranes and how an effective hygrothermal analysis can help establish a healthy and a sustainable building. And so we manufacture and distribute construction membranes which are used through the facade of the building. And when we're traveling around the world where we're developing new markets, one of the things that we need to do is understand conditions which are going to affect the performance of the building. whether it's from Seattle or Sydney, Scotland to the Kingdom of Saudi Arabia. Every building, every design, every climate is subtly different. And so we need to be able to understand how we can get the most out of the structure, most out of the project. And so what we do is we evaluate the building. What is the purpose of the building? Is it going to be a high-rise? Is it going to be accommodation blocks? Is it going to be made of concrete or steel or a combination? And understanding the way that this building is going to perform and the purpose of the building will help us in our evaluation of this hygrothermal assessment. We also need to consider the weather or the climate. My colleague and I went for lunch yesterday and decided it would be a good idea to go and walk down the Corniche and find somewhere close to have a nice light lunch and walk back again. In Scotland, we could have done that no problem at all, but we hadn't considered the climate and we hadn't considered the weather. And by the time that we got back to the hotel, I'd lost about 10 pounds, and my colleague looks like a traffic light at red. You need to consider the climate when you're thinking about where you're building and how you're building. And finally, the occupants. Who is going to be using the building? Is this going to be a high-rise? Is it going to be accommodation blocks? Who is going to be getting the most out of the building? And again, the purpose of this is the volume of moisture and the volume of cooling that it's going to require to maintain a healthy internal space and to have a healthy building that's sustainable. So once you've considered those things, and once you've established those things, the next thing is considering how you're going to heat or cool your building, and the movement of this heat, the air, and the moisture throughout the structure, the substrates, and through the structure of your buildings. And so in the Northern Hemisphere, we are a warming climate. We're heating our internal space. In areas like the Kingdom of Saudi Arabia, obviously, you're very hot on the outside, and you're doing your best to cool the internal space to maintain a comfortable living environment. And the challenge is ensuring that all the individual elements that are throughout the structure work effectively in a way that you're providing an economic to run, healthy internal space, but also the fabric of the building isn't damaged by something called interstitial condensation, where warm air hits a cold surface, condensating like on the shower, you see that the moisture kind of forming on the glass. This can damage insulation, this can damage the fabric, and in turn, it can create a difficulty for the inner air quality for the inhabitants that are going to be there with mold, and then obviously causing respiratory problems. So the vapor drive from the outside to the in also determines the type of membranes that you're going to use and the position that you're going to use them. You're wanting to protect your insulation, you're wanting to ensure that you're not trapping moisture in positions where it could create problems in the future. And generally, once you've closed, you put your facade on, you won't know there's a problem until you have water pouring through the ceiling or you have people struggling to breathe properly. And so for speed for today, what we're going to do is just talk about two different kinds of membranes, two classes of membranes, very generically. One is an air and vapor control layer, often called a reinforced vapor barrier. And its function basically is to stop the movement of air and moisture from one side to another. Depending on the vapor pressure, depending on the tensile strength requirements, you may have a lighter weight one, you may have a heavier one. There are fire-rated membranes. And so all of these things need to be considered, and critically understanding that type of membrane is effective in a particular position. If you position it incorrectly, you're creating problems for yourself rather than solving problems. And also, we've worked a lot in Dubai and Qatar. Having a durable and reinforced membrane is also very important due to the installation. The quality of workmanship can dictate to a great extent how effective the product is. The slightest snag or tear in a single-ply polyethylene membrane will shred and immediately you've just made that barrier completely ineffective. So having a reinforcement scrim, having the correct tensile strength, limits the potential for damage through the future. And the other type of membrane is a vapor permeable membrane or a breather membrane. And this could be airtight or it could be air open, depending on the application and the requirement. In the Northern Hemisphere, we have a lot of air open membranes to allow the building to breathe, to protect it while we're constructing. But airtight membranes are becoming more popular. And as it suggests, the vapor permeability is important because if there's moisture trapped within the fabric of the building, whether it's a wet trade or whether it's the occupants, you want this moisture to leave the building. You don't want it trapped. These are generally moisture neutral, which means wherever the vapor drive is, the moisture moves backwards and forwards, but that's important as well because, again, you don't want trapped moisture anywhere. We have membranes which are mechanically fastened. Also, we've developed fully self-adhered membranes. So when you're installing them, you don't have mechanical fastenings. You don't have the issue where sometimes you will have air getting trapped behind the membrane and billowing and ripping away from it before it's installed. And again, there are fire-rated ones, there are UV-resistant ones. There's a whole range. So there's different membranes depending on the application and the requirement that you may have. In the UK, we reference BS 5250. I know in the Kingdom of Saudi Arabia it's SBC 201 CR, but they're very similar in their principle and at their core. These are guidance documents that give code requirements for managing moisture, different types of assessment methods, and standard definitions to enable you to create a suitable building. And I love the tagline, the mission statement, I suppose it would be. The aim of the code is to improve the efficiency, safety, strength, and sustainability of buildings. And I think that's exactly what we're trying to do at the Proctor Group, where we're looking to improve the quality and the efficiency that we have and do it in a most efficient way possible. And as I'd alluded to earlier after my lunch walk yesterday, understanding the climate here is critical. On the interior, it's going to be very hot, very arid, very dry. Kind of around the coastlines, it's a lot more humid. And then at nighttime, there can be some big temperature changes. So understanding and appreciating these differences, again, will influence the type of products you use and the position where you would use them. So we use a dynamic numeric system or simulation to quantify the movement of heat, air, and moisture through the fabric of the building. And if I can get this, oh, no, wrong button. Each of these points here are elements within the building. And so they each have characteristics that are quantified. So they'll have resistance, they'll have thickness, they will have thermal values. We consider things like the finish. Is it reflective? Does it radiate? Is it a radiant surface? We look at things like the climate, the location, the altitude, doing our very best to ensure that we are getting the right data input to give the correct results. And we will run these different results, we will quantify these things, produce reports, and what we are doing is proving or disproving the product, the position, and how effective it is. And so the red line is showing us the temperature range throughout the lifetime of the building. So this is different from some other methods. Glazer method's a well-known one. In respect to this is a dynamic one over the lifetime of the building. So this will go for a long time. And so temperature, the water, moisture movement, and then the blue line at the bottom, which you can't see, is the amount of water that's contained, and it's practically zero. For time, we'll skip that one. So this is a project that we've recently concluded called St. Sidwell's Point in Exeter in the United Kingdom. And this is the world's first passive house sports center. And so it was designed with the passive house principles where you have efficient materials, you have highly effective detailing, and the way it's constructed limits the requirement for energy input throughout the lifetime of the building. And then this is monitored from the point where it's handed over. So they're able to ascertain how effective it's being. So airtightness is one of the important parts to do with that. And throughout the project, there were different substrates, there were different finishes, there are different application zones with high moisture at the swimming pool, gyms, office space, all these different things had to be considered. We had to look how they were going to interact, how the moisture and the air was going to work its way through the structure of the building. And again, we quantified this using our software that we're using, and we were able to show at each section, at each point, at each critical area where there might be difficulties, we were able to propose the right membrane in the right position, which would help them achieve the best results for an energy-efficient building. And kind of going back to the sustainability and the efficiency of a building, you know, I think one of the most frustrating things for consultants and for designers and for architects is to have the concept on paper and then pass it over to be constructed, and it gradually gets deconstructed as it goes down the chain. What we try to do is support these people, the specifiers, by ensuring that sufficient training for the installers is provided to make sure that detailing is pre-qualified before they go on site. So we'll do mock-ups, we will give lessons and training and support. We'll explain how to effectively detail. It's amazing how you can get a wonderful facade on the building and leave the joints open, or penetrations where air is leaking through, and that doesn't lead to an effective design, and it doesn't lead to an effective building moving forward. I'm not sure many of you know, wind washing is an issue where if you don't protect your insulation, you can be reducing its efficiency. It becomes less effective, and therefore you're putting a greater strain on your energy to maintain the cool area inside. So again, making it airtight, keeping it clean, and making sure that there's no condensation forming, which is going to reduce the efficiency of your building. And again, just looking through some of the details, the different areas, the different substrates, the different products that were used to give the whole effect of an efficient sports center from the outside. So at the Proctor Group, we have a range of membranes. As I said, there's two main membrane classes, vapor barriers and breather membranes, but we have a range depending on what's required, the legislation. Does it need to be fire retardant? Does it need to be UV resistant? We have a range. We have experience in working in these type of climates. So we're here today. We've been very enthused by what we've seen in Jeddah, very encouraged by some of the conversations that we've had already. So we're here. If anybody's got any questions or wants to learn a bit more about what we do and how we do it, we'd be delighted to speak with you and work with you. And thank you very much.
Thank you very much. Thank you very much, Jeff. So speaking of breather membranes and breathing, we now have a 20-minute break for you guys to breathe and have some coffee. So please head to the exhibit hall and avail the breakfast. We will reconvene in 20 minutes, all right? 20 minutes sharp. All right, everybody, please take your seats. I hope the break was nice. Got a dose of coffee, bit of food, woke up. The next speaker, starting the next session, is one of the oldest minds of architecture of Jeddah and the country, representing Zuhair Fayez Partnerships. Please, warm applause for Dr. Hassan Waqid.
I'm so happy to be here with you. I'm just trying to inspire you by our projects and our experience and how we think, how we develop work. So when we start, it's always a problem. How can we be creative? Creativity is a matter that we have to understand and evaluate. Simply that when we create, always it's a solution for a problem. That problem, it needs a stimulus element that they can, through create a simple or something that it looks for others when you always notice the creative people are always vague and not at the very beginning people appreciate it or understanding what they are doing. So the most important when I say it's a creative work, it should be productive. It should add values like expressive, productive, innovative, many things. I don't want to go much on this because I have a lot of slides, and forgive me for that. So I'll pass it quickly. In our process, we are not, as architects, we don't work alone. We work with a lot of disciplines, and it's a problem about how to save costs, how to be effective. So at the very beginning, if we are not understanding how to design and make it in a proper way, meeting the needs, so we will face at the end a big, serious cost destruction or a serious conflict. And maybe at the end, maybe when construction comes down, maybe demolition will be there. So we'd like to avoid these things by doing it at the very beginning in a proper way, covering all the disciplines and layers and understanding the needs. I'll talk about my experience about the project Handicapped Center. It is in Malik Road. And we started to design, we have to understand. Understand what? What is rehab? Rehab is not a hospital. They used to say at the beginning, hospital, but it's not a hospital. In the hospital, doctor used to be the one who's acting. I don't know what he's doing here. But in rehab, the patient is the one to act. So we have to create and encourage the environment so that he can depend on himself. So from that, we understood what we should do for them. We should not forget the sympathy and forget the what human needs to associate with buildings. So when we say children means like the growth. Understanding, I'll not go in details, but in general, growth are always in two layers, either cells to be multiplied or layers to be overlaid or above each other. So how can we go through tradition and understanding the culture and reflecting in a childish way? Anyway, we got a certain vocabulary here. That vocabulary is to make us successfully create a design matching the tradition, and at the same time applying the needs for the rehabs. It could be through playing images. It could be through understanding the referral of the sky, either night or day, and geometry. It should be an learning experience. And at the same time, we have to provide comfort. The result is like this: tradition with children, creating new playful image. So that was the result for the front elevation. Afterwards, we have noticed that handicapped children, you cannot push them to teach them. They will go reluctant, and maybe they will not listen to you. So we noticed that if we create a social environment, they feel peace and they feel happy within the space, so that through this, you can rehab them. Actually, we are not the one just to have a prejudice vision to design. We learn from others and we make questionnaires and taking results. We have discovered from another existing building in Riyadh that the social cell is the one suiting them. So that we have created a unit here, and that unit is, that one. You've seen it before. It's a social space, so they felt they are happy with, they are not reluctant, based upon we have created the general geometry for that. That is the result, actually. If you notice here, that we have the entrance, we have the rehab area, we have teaching area, and the hospital, we can say, or rehab center for training and vocation, and then the residential at the end. This building is existing. So that here is the result. That's the main gate, reflecting the meaning of the air, of the wheat, children images, culture reflection. The gates even, you see here, the colors and the feature, the geometry that children can learn through, and so on. Everything, everywhere is cheerful, social, and learning environment. Now when we go on another layer of designing, when we talk about aesthetics and art, actually it is a multiplication and overlays of many aspects. I'll not go much on this, but we should learn that there is a perception. You have to be sure that people can associate with what you are doing and have the reaction you are looking for. And that comes by many components. I simplified it here. I'm worried about time, so I'll just pass it. Another critical experience we passed through, it is in Abha Asir, King Khalid University. King Khalid University is in a place where has a lot of boulders and green areas, and something that when we looked at the very beginning, we felt it is terrible. We can't associate with, we can't make design. It was a competition, by the way. So these are the competitors. We shared in the competition reluctantly, but at the end we wonder that they came to us, they say you are the most suitable design, proposal for what we are looking for. Why? Because it's not about the jury. Jury, they cannot have time enough to understand and to absorb the site. But we've been lucky that King Abdullah Institute, they've been in the site 4 years. So they have already recognized which one is the most suitable based upon their background and history problems they know. So that, you see here, this is the site, has a lot of valleys, has a lot of soil, natural resources, rich soil that we shouldn't touch, and a lot of, neighboring should be, they have to create something about them, how to interact with. A lot of boulders and hills, something that's very tough to deal with, but we've seen it in another way. We said it's a positive elements that we can deal with. There is no necessity to have landscape. We have nature here. So that we can have we create a zoning and nature private and semi-private and so on, and we use the site as to the maximum things here. I'll just brief it to you and it will come afterwards. The only two roads adjacent here, we said that this road is for the public. Whatever precious element this university can offer, we have to donate it to the society. So all the culture centers elements we have, allocated there. Our experience about how to design, we said, okay, if there is a valley, we go like a skywalk. We interact with rocks. We go back and here with these elements, precious rocks elements to maintain, and then we proceed so on. So the result came like that. Here it is. If there is something, I make a rupture to permit it. Rocks, we celebrate it as if it's the element that would like to inspire a student through, and so on. We shouldn't forget that Asir has a special tradition. So we wanted to reflect that. In the same time, there is an academic approach we have to go through. So at the end, we get a vocabulary in between, something modernist, modern, at the same time related to the culture, and the other layer that interact with nature. So that the images we tried to do. How it is built, this is all the photos. We got that plaza, we say all what we have within the program of the university to be for the, for public use, to be at the ceremonial plaza. So it's like a donation, like the culture center, the museum, the continuous studies and whatever. And then the main building is as if it is monitoring all, so it's the only one became like a tower to reflect this. That's the end. We shouldn't go in details. Time is running. But it's okay. You notice through the reality, we understood that we have to enrich the environment by having many layers, especially for the student who in that age, they will never forget such days when they've been in the school or in the university or in the academic environment, so that we enriched the spaces for them. Rare to find. For sure, this is some elements we are responsible for, sustainability, recycling, and so on. I give an example here about the library. The library, we notice that it is, if you notice, please, it's hugging the nature inside, so we got a tent within the courtyard and nature plugged in. So you can see it like that. Here it is. So they can enjoy the environment. I see it is really a very special, beautiful environment, not like any other arid environment in Saudi Arabia or such Riyadh or whatever. And so on, we try to break, to permit the building passing by, and then to let the nature coming through, and so on. That's the result. You see here, the rocks as if it's the gate, 2 gates here, and that's the ceremonial plaza. Everybody can approach it. And for the, here museum, the central hall, and the auditorium, and whatever, many elements that relates to public was there that so they can have access to. Here is the main building. That's the, again, the museum and the culture center, continuous study, and then the din ship afterwards, and then going on around the rocks, and with a lot of variation. There is no prototype here. A lot of variation inspired from the culture and inspiring the student with such variety, so they can produce and be inventive. Rocks is the element in the landscape. We got bridges to protect the nature, passing all the way, and so on, and so on. Even with the activities. Yeah, now we will come to Dar al-Hikmah. Dar al-Hikmah is a project university. It's a project that has no land, almost 100 by 200. How come I create a university within 100, 200 site dimension? Anyway, we made our best. And what we just tried to do, because there is no landscape, nothing outside, and internally, we inserted light to come in every space. And then we tried to compensate them afterward in Abhor by having another building with another dimension, futuristic, and so on. Open Arab University, we open, culture is reflected, we open as if it's a grand gate, come down, you are welcomed, and so on. American school in Jeddah, modernistic, museums in Riyadh, aircraft museum, high tech, and how we presented that, you see like a kite with the sky and the, and the track. So first phase was just constructed. Another one here showing the defense, the Air Force's defense, that this is tradition and thermos, they monitor through the thermos and so on. And now the technology on the other side, they can experience both. Other thing which is challenging is the Prophet Museum. We wanted to reflect his struggle for Islam. And with a lot of battles happened and expeditions. So we wanted to have the elevation as if it is like a display for that. Another project in Al-Haram area, it's part of Al-Haram in Mecca. So how can we plug building within Al-Haram At the same time, you see here, this is the northern, those who are familiar with the northern part, expansion part of Al-Haram, that's the building, blending, complementing, but actually it's a great library and culture center. So, I mean, how we accept and complement nature and built environment. Places for meditation and inspiration, and so on. Now, it was a big challenge actually in Argentina and Johannesburg. In Argentina, they wanted to create a culture center, King Fahd Culture Center, and we said, what can we do? Modern, yeah, they have done it in Europe here, modernistic, but we want to touch the feeling and the senses. So we wanted to remind them of the background of their culture. Most of the Muslims there are from Syria, Lebanon, and so on. So we'll try to reflect that and teach their children how their culture, their language, to be sympathetic with, and so on. Now modernistic and having a modern mosque in Mecca. So that we have utilized, technology in every aspect, precautionets, solar panels, and it's an image that I mean people can appreciate, and you feel that there is something could be far away from classicism, and there is possibility for something acceptable. That's the mosque in King, I think you passed by King Abdulaziz Airport. And this is Al Safwa, it is at the plaza of Al Haram. How can we create something to complement, yet not to be overwhelming? So I think in a very narrow width, we made our best here. I think it is successful. This is the sketches before we, the other, should go down, back, sorry. Here, the other endowment, you remember that there is one with the clock on one side, high rise. Here we wanted to give good example. From Al Haram Plaza, we should not see anything. So the first building is really overwhelming, and when you hover around, you experience it too much. But we try to make the second endowment that no one inside the Haram would see the buildings. And even to give the flow to Mina, the other side of the sacred location. Another museum in Junadiriya for Aramco. So we see the mud and the technology blending together. And tour beneath the earth. So you should see what Ministry of Petroleum is doing inside. So you can explore under the earth how how they work. And now in a very high-tech project, it is in Riyadh, the ITCC tower, and the surrounding development. It is actually for internet, and like what's happening in Dubai. But you see the vocabulary here is very futuristic with very rich materials, utilizing everything, tents, steel, marble. So it enriches. That is Lexus in Riyadh. And we say in the highway that, okay, that is our product. So we show it through, Bistum comes up with a special car to be displayed. Now, sorry, what's happening? I'm sorry, I'm not familiar. So I'll go back. I think time is okay. Here, SABIC. SABIC is the greatest industrial company in the kingdom, and that's their headquarters in Riyadh. We say that's the gate for the future. And it welcomes, it's simple, it is related to tradition, so that they accepted it was international competition. They liked the design, and thanks God that we won it. And it's now in the 8 if you want to know. And they have learning, sorry. Yeah? They have learning, I don't know what's happening here. Yeah. What happened? I think.
I think you ended the presentation there.
No, why? Still something wrong. Maybe I made a mistake here. Yes. This should be.
Over here.
Where is it? So I'll have 2 minutes more. Yeah?
Over here.
Yes. Here it is. For the Ministry of Interior, they wanted to have General Directorate. So we took a lot of time to convince them of what we should do, a lot of option proposals. But at the end, you see here, it is the main entry that supervises everything and welcoming the people. In the same time, it has, futuristic with the culture merged together. This is faceted glass. The feature is opened to outside, inside, and I think they built it as a prototype in most of the kingdom regions. We are happy with this. And that's the Emirate, Medina Emirate. How we transfer from the modernity to classicism to cultural emphasis, and that's the design for Mecca Emirate. And at the sea, at Norris, we proposed a futuristic modern building to complement the sea and the youth. And thank you very much. I'm sorry, I haven't slept enough so that I'm not in that good mood to explain. And bless you all. Thank you.
Thank you, Dr. Hassan.
Thank you.
Thank you, Dr. Hassan, for this huge array of projects. Zuhair Fayez never disappoints. For our next speaker, we have futuristic 3D masterpieces. So please open your eyes wide for Mr. Oliver Rohde from Sile. Thank you.
My name is Oliver. I'm the managing director of Sale and responsible here in the Middle East for our office in Jeddah, Saudi Arabia, and in Dubai. First, I want to start my presentation with clearing up some misconception of Sale and SEDAC. Very often, SEDAC and Sale will be brought into one pot, which is actually not the case. Sale is what we are, is a facade contractor. The owner of Sale is the family Sale, and the family Sale also owns SEDAC. SEDAC is a production facility where we process glass of up to 20-meter length as a flat glass, and in sunglass, which also belongs to SEDAC, we process curved glass of up to 18-meter length. So if we execute a project, we go and buy our glass from SEDAC, but do not necessarily have to buy it from there. We can also go to other glass processors and buy the glass somewhere else. The same way SEDAC is also pricing the glass to our competitors. This way we remain independent as two independent companies. Sale has offices worldwide. Our head office is in Germany and in Austria. Locally here we are in Jeddah and in Dubai. Projects we are focusing on is mainly steel and glass structures, membrane structures, unitized facades, not so much in the Middle East, but internationally, and a strong focus we have on all glass designs. What you see is Fifth Avenue, Apple Store in New York. These are some projects we have executed in the region. Lately finished Abu Dhabi Apple Store in Maria Island, and I will straight jump to the next project, King Abdulaziz Center for World Culture, also known as ITRA. I want to talk about 3D designs, and I think you would agree with me that's a masterpiece of 3D design. What is the complexity in this, the 3D as such? We have 30,000 square meter of three-dimensional facade, and we created this with 350 kilometers of stainless steel pipe wrapped around the facade. It also includes 2,000 square meter of insulated glass panels, 1,700 square meter of twisted glue lamp columns, but the focus today is the 350 kilometers of pipes. How did we start the project? Of course, we first start collecting the basic parameters like the specification, like the local requirements, etc. Then we jump to the 2D design where we do the detailing, the structural calculation, and for this project, very important logistical concept. 350 kilometers of stainless steel pipes, you can imagine average pipe length is 7 to 10 meters, so we're talking about 50,000 pieces of pipes which have to be placed in the exact right location to, at the end, form the three-dimensional form of the envelope. After that, we went to the 3D modeling, CNC data generation, and subsequently manufacturing. When I said 2D design, we do the structural calculation, but we have a strong focus then also on the detailing. What you see here is a pipe connection, and as the word says, the first function of a pipe connection is connecting two pipes. The second function for this project, even though it is stainless steel, we don't want to get water into the piping to avoid any form of corrosion inside the pipes. So this is also the reason for the gasket at the pipe connection. And third function is the comfort of the user of the building. Through this pipe connection, we achieved that there, even through vibration caused by wind or any other weather conditions, there is no noise disturbance from the facade. And the next step, we developed the envelope as the 3D model. We formed the complete surface model. And after the surface model, we defined the design areas and created the system points of the entire facade. Once we had the system points, we were almost there, that we had the pipe geometry. We still had to define the center lines of each individual pipe. With that, we created the length and the exact radius of each individual pipe, and then we modeled the pipes. After this, we had the complete geometry of every single pipe of the project. With this, the 3D modeling was done, and we brought this data into the CNC software. For this, we had to use a kind of artificial intelligence. As you may know, if you start bending steel, it has the intention to deflect back to its original position. We have not a radius at one position here. We have many different radiuses, a spherical curved pipe. So we had to give this information to the curving process, that we bend the pipe or overbend the pipe so that after deflection, it has exactly the right radius to reflect the surface we saw at the beginning at the facade. So that was a sort of artificial intelligence we used. After putting all the data into the CNC software, we started the manufacturing. We started with the printing of the drill holes. We marked everything at the pipe. We started the bending process, and then we did the first level of quality control by laser measuring every single pipe. After that, we did the micro labeling, important also for the logistics, that every pipe gets its individual name. Next step was the drilling, cutting to length, cleaning of the edges, and the end form, where you can see here again the detail which I showed you at the beginning. Last but not least, we did a QR code for every single pipe. The QR code was the key for the logistics, for the site logistics, but also contained all the design information for the pipes, and also contained the installation instructions for our installers on site. That means the installers could read the QR code and knew exactly at which place this pipe has to be placed. So very crucial for the logistics of the project. Finally, we did the wrapping of each individual pipe, packing, and shipment to the site. Here's some picture during installation. Here you see the brackets at the back for the fixing. Here we did some value engineering for the brackets itself, and eventually we had that product, and for me personally is one beautiful piece of 3D design. The next project I want to show you the project we have executed in New York, 33rd Street, Penn Station, the entrance for a metro. It's not a big project, but unique and complex for us. Yeah? What you see here is AECOM SOM was the architect. What you see is a cable facade and 139 pieces of double curved glass, so completely three-dimensional. The entrance is 45 degrees inclined, and the inclination, the so-called hockey sticks, go into the spandrel panel at the bottom for the horseshoe form. You see 105 tons of steel, 277 square meter of cable facade. Here's some systematic view to the project. You can see at the bottom the horseshoe itself, the box sections left and right, and the hockey sticks which were connected to the box sections. And on top of it, we had the crown, which I'm referring to a little bit later. In the middle, you see the cable grid. The design of the cable grid and the steel structure was an iterative process where we had to define the exact strength or tensioning forces for the longitudinal cable, because this force had to be strong enough to hold the tensioning of the transversal cable. And this then again had an impact to the structure. So it was an iterative process until we finished the exact height of the sections, of the steel sections, steel structure, and the cable grid. At the end, you see the 3D model of the glazing, and you see at the you see at the crossing points of the cable, you see the fixation of the glass. We choose here a fixation via clamp fixing. It could have also been done with a spider fixing, but that's a method Seele is not using anymore since several years. For spider fixing, you always have drill holes into the glass, and this is always a reason for delamination of the glass. To avoid to the maximum possible extent to maintain the quality, we avoid these drill holes, so we choose here a fixing with clamp fixing. Here's some pictures from the production process, also in our factory in Seele Pilsen, Czech Republic. The box sections had to be designed the way that it could also contain the drainage and the cable works for the illumination of the whole project. Here the spandrel panel, 70 millimeters of steel forming, and on the right side you see the A-frame, the hockey sticks for the A-frame, and here you see the crown. The crown was also all the information, like before, went to the CNC software and was then cut from one block, 400 millimeter of steel, and the holes which you see here, these are the inlets for the tensioning tool for the tension rods. This is where all the tension rods, the longitudinal went. Here the testing of the entire structure. So we assembled the complete structure without the glazing, but we assembled the complete structure, tested everything in our factory in Czech Republic. So we have all the testing facilities there. And here's some impressions of the site installation. We delivered everything just in time. So the whole installation took not more than 3 weeks for the structure, including the tension cable. Subsequently, we did the installation of the double curved glass panels. And at the end, you see here, the sealing of the joints was with structural silicone. So, and one gimmick at the end, also the spandrel panels from the inside had a sticker of the complete New York City map. So for me, also a fantastic project in 3D design. These were some projects we have executed in the past. We're done with these. I now want to show you some projects we're executing right now. One project is the Henderson Tower in New York. Apologies. Henderson Tower in Hong Kong, which should be finished this year. For the Henderson Tower, the Seele Group basically did the complete glazing, even though Seele only did the podium, the first 6 floors of the 3-dimensional curved glass, and the roof structure. I now want to show you the video that you see the exact scope of Seele. Here in green, you see at the bottom, the first 6 floors is complete 3-dimensional bent glass. in red, you see the columns for which we did the stainless steel cladding. It's a stainless steel cladding, 4 millimeter. We produced it in a 250-ton press and is complete mirror polished. Then you see the podium where we have 11-meter high glass, complete structural glazing without any steel fins, without any glass fins. Total glass build-up is 7 times 15 millimeter. We go on to the main facade where we delivered, or SEDAC delivered the glass. Installation was done by a local glass facade company. And then we did at the roof the complete structural glazing of the roof, the facade as well as the skylights. Here's some pictures also. Manufacturing of the steel components happened in our steel factory in Pilsen, Czech Republic. You see the mirror polished finish of this, and this is how the steel columns are cladded. Here's some pictures of the installation. These are 10-meter high double curved steel members to hold the double curved glass facades. And here the complete facade, still covered. It's the complete glazing from the bottom. I look at the time, we still have time. So this is the installation of the roof structure, roof glazing. As said, we did the windows or the glazing of the facade as well as the skylights. And at the end, a view to the almost finished project in the Hong Kong skyline. As said, finish of the project is end 2023. Last project I want to show you is new Performing Arts Center in Brisbane, Australia. What you see here is a complete corrugated facade. The single glass elements are 7.20 meters high and curved in both directions, which is also a kind of new technology in the curving process. In the past, the curving happened always in the autoclave in one direction. That means if you produce an IGU, as we have here, the interlayers and the coating is always at a different phase, and you need to be very careful in the production that you turn the glass to the right radius. What we do now is the curving in the convex and concave direction, so that the appearance, once the glass is produced, it looks exactly the same whether it is curved in this direction or this direction. So it's also a new process of the curving of the glass. This some rendering. 2021 is not correct anymore. That was the original time to finish, so 2023 is also the finish of that project. Yeah, this the last picture of this project, also a masterpiece of 3D design. And with this, I'm at the end, and I would like to thank you for your attention. Thanks.
Thank you, Oliver. So, thank you, Oliver. Our next speaker is one of those masterminds I was talking to you about in the beginning of the conference. Of course, all our speakers, but the next speaker is working on some very big projects, and I'm not going to talk about what he's talking about. However, I'll let him do it. Please welcome from Werner Sobek, Mr. Benjamin Beer.
Thank you. So a warm welcome here from the stage. My name is Benjamin Beer. I'm head of Façades and head of the Dubai branch of Werner Sobek. Now, Werner Sobek, we are a German headquartered consultancy. We're doing facade engineering, structural engineering, MEP engineering, and so-called special structures. I'm here in the Middle East since about 2007, running the Dubai office. And today I want to talk about facades, but also about human beings. And I also want to talk about what we as a human being need. I also would like to question what we're doing right now with our facades. Are we good enough? And what's going to be the future? This is what I mentioned before. We have about 350 people worldwide. Whereas Werner Sobek, we have a strong research background. The founder of our company, he's a professor. We have currently 5 professors within our company itself. We have a lot of research background. We collaborate with universities, and we're currently pushing at quite a lot of new technologies. Our offices and projects around the world, but I want to just start into a bit of looking backwards and also looking forward. So this project about almost 25, almost 30 years ago in the design, Post Tower in Bonn, done with Murphy Jahn, with Helmut Jahn. And so what do we need as a human being? Yeah, we need air, we need light, and we need food, of course. So we, with our facades, we influence, we affect light and air. Now, this project itself is a very nice example how we work together with the architects. It's about light, it's about vision. This is what we need. It's also about air. You can see on the left-hand side, you can see the small flaps. So this was one of the first high-rise double-skin facade buildings. So we have a pressurized outer ring facade. We see this so-called ventilation flaps. Now, we work together with the architects. We get, for example, sketches. This is a sketch from Helmut Jahn, very early stage in the design, setting up the idea of the facade system itself. And this comes back to what do we need as a human being? So we would like to have vision. It's a beautiful spot on the river. We need light. And also the air itself. So we're utilizing on this specific project, we're utilizing a double skin facade with an integrated Venetian blind shading. So depending on the sun position, we then put a shading out to reduce the solar heat gain, to protect people from glare. And this was already designed 30 years ago, built about 25 years ago, 20 years ago, and still operational, fully working, everything's fine. Talking about, again, the human beings and looking a bit further to the past. How did people survive in the Middle East under the very strong climate? And previous speakers already mentioned it's a very strong, especially the summer. It's hot and it's humid. And people were using whatever they had. So people in the past, in the Middle East, they built wind towers. This is what always I want to achieve as a consultant. We want to consider the local climate and also the local culture. So what people did in the past, they were collecting wind and were funneling the wind down via wind towers into a courtyard. Quite often within the courtyard, we even have a fountain with water. And this is about using what we have. And these buildings were zero energy. Yeah. Today, we heard about passive house and building low energy consumption. People already had it in the past. We then implemented kind of Western technologies in the Middle East. The air conditioning came and so on and so on. So the energy consumption was skyrocketing up. But people in the past, they were smart. And on the next couple of slides, I'm going to explain to you why this could happen. And this is about understanding us as a human being. And this is whatever we do in the future, whatever research we're going to do, it's about understanding us as a human being. And we call it so-called human-centric design. We understand us as a human being. So how did people survive in the past? In the United States, about 1943, shortly before the Second World War ended, they put people, test people, into a kind of climate room. And they heated the room up. Yeah, so people were used to kind of air-conditioned room to moderate temperatures. You can see on this graph how the heart rate and the skin temperature started dropping down with the people being exposed to heat. I think this was 40 degrees Celsius. And you can see that people acclimatize. Yeah, so people were in this 40 degrees Celsius. And then after 5, 7, 10 days, people start to normalize. So the skin temperature and the heart rate was from high getting down. Yeah, so could we live without air conditioning in the Middle East? Yes, we could. Yeah? If we switch off the AC in this room and just put it cold here today, after 5 to 10 days, we feel more comfortable. The first couple of we're going to sweat, feel uncomfortable. But this is the thing that we as a human being, we adapt. And to understand this is quite important. Now, do we want to do this? Do we want to live without air conditioning? Quite sure not. But can we find actually ways around? Now, going into kind of these kind of ideas of the traditional wind tower, we're currently working together with architect CRTKL on a project in Riyadh, which is a big shading canopy. Now, the idea is that we're creating a more comfortable outdoor environment. So people want to walk in between buildings, even if there's sun, even if there's heat. So we just want to enhance the thermal comfort of people. And you can see it's quite a big canopy, shading canopy with integrated wind towers. So we took the old idea, or CRTKL, took the idea of the old wind towers and transformed it into modern times. Now, we did the full consultancy on the structural engineering, certain other parts, the wind towers itself. So it's about getting a thermal comfort, which is good for human beings. Now, these wind towers, they pick up wind in the upper areas and funnel it down into the pedestrian area, to the walkways between the buildings. Besides the full engineering that we did in 3D for the shades itself, so these are fabric shades, so membrane shades, the nodal point connection, they have up to 60-meter span. We did parametric scripting, so we optimized the geometry of these elements from the structural engineering point of view to get ideal curvatures to reduce the steel tonnage of these shades to increase the span. But it's also about the full 3D modeling and the engineering design itself. Now, these wind towers, they're able to pick the wind from two main wind directions to funnel it down into ground flow to get a kind of airflow. Why do people feel more comfortable with airflow? Because on our skin, when we're sweating, so any kind of air movement moves away the kind of hot air above our skin. So people feel more comfortable. So even if the temperature is the same, if there's airflow, people feel more comfortable. Now, we did this full engineering, the full design. We have a rotating drum on the top left. You can see, hopefully this works. So here you can see there's a rotating drum, and it's a motorized operation. So based on the wind direction, where wind speed sensors, and the drum can rotate to pick up the wind from one side. At the same time, RWDI was doing CFD analysis, so we could simulate the wind flow and how much we can improve the thermal comfort of the people walking in between these two buildings. We call it percentage of dissatisfied people in terms of thermal comfort. So this is kind of ideas how we can at least stretch the outdoor season of people sitting outside in cafes, like in Italy, like in Spain, people sit outside, have a coffee, maybe like 1 or 2 months expanding. Yeah? The engineering itself, when there's no wind, of course, we thought about we need to have artificial wind. So we have kind of motors, we're creating an artificial wind flow through the wind towers. At the same time, we're using so-called evaporative cooling. So we have water spray system that is spraying a misting, kind of water mist into the air. When water evaporates, it's cooling down the air itself. I'm going to show later on why we're using this technology also in other areas. Now, this is the kind of level of engineering that we do. We're going full detail on all of the aspects. I want to go on. We have been the lead designer for all of the Expo 2020 shades in Dubai. Now, the Expo in Dubai, it was the first time the Expo was being held in the Middle East country. So the sunlight and the glare and the thermal comfort of people between the pavilions was quite important. So we designed these architecturally really stunning retractable shades so they can open and close. It's again, you can see the pure scale. So this is an aerial photo. You can see all of the white areas, so all these retractable shades. They were huge, huge areas to create a comfortable thermal outdoor environment for people walking between the pavilions. What we did over here, and we come to this a bit later, the fabric itself, it is motorized, it can open and close. The direction of the main tensile stresses of these fabrics are optimized in a way where these attached to the mainframes.
That we have to reduce dramatically the emissions. The announcement is to reduce CO2, greenhouse gas emissions, within 10 years by 55%, which is something different to save 55% of energy consumption. This is even more difficult to be achieved. Everyone underwrites that, but nobody really makes clear to himself what that means, because if we are not capable to change the technologies we use to produce the materials, to build the buildings, to run the buildings, and to demolish them, if we are not, then in 10 years we are allowed to build only 45% of the amount we are actually building. Means half of us is becoming unemployed. Standing in front of a problem which says, okay, either you change everything or you cannot build in the way you build nowadays, will urge this interdisciplinary process that people start talking to each other and say, either we invent something or we are lost.
And this is the thing about inventing for the future. In terms of sustainability, we need to reduce mass. And if we want to reduce mass, we need to build lightweight. And these fabrics are a perfect example how to build lightweight. Now, these fabrics itself, as I mentioned before, they're highly optimized to reduce the solar heat gain coming through actually through the material itself. But you can also see from the structural engineering point of view, there were some innovations. If you look at the bone of a human being, in nature itself, it's extremely efficient. So the bone of a human being has to be strong, but also lightweight. So within the fibers of our bones, we have an orientation in the main direction of the tensile stresses and the compressive stresses. So this is kind of efficiency by nature, what we're a bit of mimicking in our engineering design. Another very nice example, also very good for the Middle East climate, we are talking about evaporative cooling. We use water and water evaporates to bring temperatures down. We're currently working on a new development called hydroactive lightweight facade systems. And these systems are using microfibers, textile microfibers. These microfibers are in a way, so you can see on the left-hand side, this is a water drop hitting a hard surface. On the other side, this is a water drop hitting a very microfiber surface. So the water drops hits the microfiber and gets evaporated itself because of the very small scale. This system itself, we are currently using to develop a new facade system. So we're looking into the future, And our future quite often will not be how we did facade systems over the last 30, 40, 50 years. Glass, aluminum, steel. We need to get more smart, we need to get more lightweight. So this so-called hydroskin facade, we're utilizing it in a way that we want to use evaporative cooling in the facade system itself. Now, this is a kind of early product system, so we have a kind of mesh of kind of 3D textile mesh. We're putting water in it from the top. At the same time, the mesh could also harvest rainwater. We currently have a big test tower in the University of Stuttgart, so this on the left. So we're collaborating with the university. Our founder was a professor of the university for many, many years of the ILEC. So we can simulate different facade systems in full 3D scale in reality under high wind load conditions. So this system itself, we're currently testing itself. There's going to be, you can see the hydrogen on the left-hand side. The system itself, we currently have it to a stage where we can cool down the air by about 10 degrees Celsius without any air conditioning, just by the use of water and natural airflow. The system itself, this is from the ILEC, it is currently in Novois. To explain a little bit the system itself, we're doing a permeable, translucent permeable facade system. Natural airflow can go through the material itself. We're putting water spray, you can see over here. So we're putting water into the system itself. Natural airflow goes through the system, and we're cooling down the air by over 10 degrees Celsius. This system itself, we're heading for both buildings, but also getting temperatures down in a kind of larger scale environment. We're talking about, for example, microclimate change in cities itself. There was a graph here. Now, let me go back. Now, talking about textiles itself, high-rise towers, we're still cladding high-rise towers with aluminum, steel, and glass. What if we're using translucent fabric materials, lightweight translucent fabric materials? This, for example, a product of us. This is a test tower of an elevator company, one of the biggest towers currently clad in lightweight textiles. I just want to show you the kind of options that we have about the future of facades. What are the next steps? What are the new materials that we're using? And talking about human beings and light. Now we talk about a lot of wind and getting air temperatures down. I also want to talk about light, and this is another pretty big research that we're currently doing. We are using quite a lot of light. This is one of our projects over here. It shows a bit the kind of current futuristic Expo Astana thing. I want to go into light again. Now, we human beings, we need light. If we don't have light, people go crazy and people would die. And the quality of light, this is a current thing that we are very strongly looking into, especially in the Middle East. These people over here, also in this room, we have light, but we only have artificial light. We don't have natural light. People know since decades that people need natural light. So this is an office in the 1970s. People didn't have natural daylight. So this is when the so-called sick building syndrome was created, this kind of thing. People got aware that we need natural daylight. This is a map of the United States. On the right-hand side, we can see on this side, we see the percentage here of people with depression and anxiety. You can see there's a very strong correlation between people getting depressive and sunlight. So all of the southern states, like California and Texas, they have a lot of sunlight, and they have the lowest degree of depression, of mental illness of people. So we know very clearly we need light. But the question is, what kind of light do we need? Now, we as a human being, you can see on the left-hand side, this is how much time we're spending. And we spend most of our time indoor. Yeah, so about 87% of our time we're spending inside rooms. So we as a human being, we became an indoor species. No longer outdoor, we're now inside in rooms. So the glass that we're using became so important for light. Yeah, indoor species, light, glass. Now we're currently running certain research for the one with Guardian glass. Now we need natural daylight to produce vitamin D. Yeah, so this is what our skin needs. There are even apps on your mobile phones where you can check how much sunlight you got exposed to your skin. What we're currently looking into now, this quite looks a bit complicated. This is about the time between like 1960s to 2005, and this shows what kind of quality of glass we're using. And our glass is currently optimized to reduce the solar heat gain. Yeah, but is the glass at the same time optimized for us as a human being? So what do we as human beings need in terms of solar spectrum coming through the glass? This is currently unknown. Currently, the glass industry is optimizing only to reduce solar heat gain for shading coefficient. More visible daylight, less shading coefficient. But the visible daylight, what we get is from 380 nanometer wavelength to about 800 nanometer wavelength. So this is a visible spectrum for our human eye. But what if we need more as a human being? So this shows a bit the kind of transmittance through the glass itself. And over the decades, our glass got more and more solar selective. Yeah? And what we are right now, this is so-called triple silver low E coatings where we are over here. Yeah? So the whole infrared spectrum is blocked. Yeah? And also certain other spectrum is blocked. So when we talk about natural daylight coming through glass, with modern glass, it's no longer natural. We're getting a filtered spectrum that comes to our modern glass because the glass is purely optimized, reducing shading coefficient. So this is what we're currently going into, and we try to then understand what we need as a human being with medical people, with doctors, with psychologists, and so on. Now, what about the wavelengths? So the infrared wavelengths, we know that, for example, Parkinson disease is nowadays treated with certain wavelengths with a red light, which is currently filtered out. We see, for example, newborn babies, they get jaundice. So meaning that your body is not able to clean the blood of the very newborn babies. So they're getting treated with a certain blue light spectrum of 460 nanometer wavelength. Yeah? We know that all of these lights, all of the spectrum of the light has a certain effect on us as a human being. Our day and night rhythm, the so-called circadian rhythm, so when we wake up in the morning, we need blue light. To wake up, we need blue light because our body, we as a human being, we got adapted by nature over the millions of years when we exist. So the natural daylight coming from sun during noon, 12 o'clock, with a peak of blue light. Then in the afternoon, our light is getting more orange, yellowish, more reddish. And this is how our human brain works. So we need this blue light about this wavelength, 409 kind of wavelengths, and this is picked up by our eye for the so-called circadian rhythm. So this blue light is also, for example, all of your mobile phones, your iPhones, Samsung phones, or whatever, you have a night mode, you have a blue light filter mode. So usually after kind of lunchtime in the afternoon, it's filtering out the blue spectrum on your phone so that you as a human being, you can get asleep. Yeah? So too much blue light stops you falling asleep. Now, in terms of light transmittance itself, we are currently working together with the Draft Dienststandard in Germany on re-evaluating glass panels. So our coatings on the glass, we not only look into the visible light transmittance, we also look into the so-called melanopic light transmittance, which means that we re-evaluate the transmission of glass for what human beings need. Yeah? And talking about this kind of blue light spectrum, you can see here the wavelengths and the color itself. Yeah? And what do we like as a human being? So this wavelength, about 400 nanometer wavelength for the circadian rhythm, is about very light blue. It goes into the light green. And these are two colors that we as a human being like to see. For example, this one, you like glass, you like green. And when we optimize the glass in a way that we're getting a more natural kind of spectrum of the solar light coming through the glass, then we're winning because we can enhance the human well-being. I should go through this relatively quickly. And now talking about this kind of spectrum that we need, and this is also another thing, talking about green facades, so coming from the glass, going to green facades itself. Now, all of these apartments next to Central Park, they have a higher value. So people like to look into the green, yeah? And this green, if I could quickly go back a couple of slides, at exactly about 500 nanometer wavelength. This is what makes us, a human being, happy. Yeah, it's the light blue, the light green. Now, how can we bring this also to our facades itself? Also, what we're doing now, there's quite a lot of so-called green facades. So we're optimizing everything to keep people more happy, yeah, to enhance human well-being. And this is one of the largest green facades in the world where we consulted the architects. So we are bringing Central Park, and it's no longer a park, it's getting a building. Yeah? So what if we say we don't need a park because the buildings become our park? Yeah? What about the property value? Because as I mentioned before, the properties next to Central Park, they have extremely high value. What if across the street, the apartment, not looking at a gray facade next door, they're looking at a green facade? And also the green facades help against the so-called heat island effect in our cities, because all of these living plants, they reduce local temperature. Yeah? So for the microclimate of the city, it's very positive. We get better air quality, we reduce noise levels, and so on. Now, these kind of facade systems, we are working together with botanical experts. So what kind of plants are perfect for the local climate? We're also doing this actually for Middle East projects. So what kind of plants need less water? What are quite strong and robust? And you can see the facade system itself. We can see this kind of planter boxes. We see the quite sophisticated irrigation system over here. We see the water outlets to drain the water out and then to recycle even the water. And this brings me also almost to the end of my presentation. I hope I was able to give you some new thoughts, some new ideas, and say thank you.
Thank you, Benjamin, for this absolute masterclass in facade design. That was really, really jam-packed. Please catch this man in the break because he has a ton more ideas. And now for these beautiful facades that we design and we build, if you can't access the facades, then you simply cannot build them. So from Cox Gomel, our next speaker will explain how can the access systems be used in our designs. Mr. Kelvin Tan, please, warm applause. Thank you.
Good morning, everyone. My name is Kelvin Tan. I am actually based in Dubai. I am leading the operations for Cox Gomel and Mentec brands of BMU. I'm also the managing director for Middle East, Africa, India region. So I've seen a lot of nice presentations today featuring nice buildings, facade elements, etc. So imagine if for a moment that you've built a very nice building, but you're unable to maintain the building or to keep it clean. What are you going to do next? So this is what we're going to discuss today. So the first point, I would introduce a little about our company, what we do, Cox Gomel and Mentec, and our partnership with our local distributor, Masa. We will then touch upon building maintenance units being a primary access system. I will also discuss about the total cost of ownership in relation to the lifespan of a building, why after-sales support is extremely important and crucial. You're investing in a proper equipment, but definitely you want to extend the lifespan of your equipment as far as possible. And as we move into the new age or the new era of technology, we want to make use of digitalization. How can digitalization enhance the facade access equipment that we have today? How can we modernize our systems? And obviously, we are in the business of transporting people outside the building. You definitely want to have a safe, reliable system. How do we do that? I'll discuss about it today. So I'm not sure if it will work. This is a short video presentation about facade access industry.
Mentec and Cox Gomel are global leaders in the facade access industry. By facade, we mean the external skin of the building, in which we provide systems to transport maintenance operators on the outside of buildings. Our range of facade access solutions consists of ready-to-order modular configurations from Cox-Camille, which are ideal for buildings of uniform shape and standard heights, through to Mantech's custom made-to-order solutions for super-tall skyscrapers and buildings of architectural complexity. Typically, building maintenance units can be used for window washing, replacing window panels, replacing lighting. A project we're very proud of is the Burj Khalifa. This is the world's tallest building, standing at 828 meters. It reaches to a pinnacle, so there's no natural roof. We have 18 systems deployed throughout the building, which are garaged into the side of the building, and these units emerge and track around the outside on stainless steel railings. The facade access industry is a fast-growing industry where demand is created by advances in new construction techniques, which are driving trends such as super-tall and mega-tall buildings and more complex facades. Mantech and Cox-Camille are involved very early on in the building's conceptualization with the architects and with the developers. Working with the main contractors, we design, fabricate, assemble, test and install ourselves, providing an end-to-end solution. Mantech and Cox-Camille are renowned global leaders. We cover the world through a network of our own sales offices and third-party distributors. On top of that, we have distributors covering projects all over the world.
Okay, so as a combined entity, Cox-Camille and Mantech, we are present in more than 50 plus countries. We have combined more than 15,000 units deployed around the world. We are ISO 9000, 14,000, 45,000 certified company. The tallest top 12 skyscrapers in the world are done by Cox-Camille and Mantech. As a combined entity, we have more than 70 years of experience. With Masa, our most reliable partner in Saudi Arabia, they have more than 15 years of experience in this market. And then we have more than 60 members within Masa itself involved in not only the sales, but project management of the business, as well as after-sales support. And they're actually a purely dedicated facade access solution provider. Yep, as I mentioned, they're very, very specialized in the facade access industry in Saudi Arabia, currently having more than 200 machines under maintenance. Here are some of the examples of their partnership locally in Saudi Arabia. So on the left, we have quite an impressive list of reference, also on the right with Cox-Camille. You can see the most prominent buildings, probably you could recognize most of them. They're all done by our companies. Burj Khalifa is currently still the tallest completed building in the world at 828 meters tall. We have more than 18 systems all around this building. You'll notice that the facade is actually extremely special. There's no flat roof to allow for any BMU systems. So all the systems are actually deployed within the building. Here's a very short presentation about
global leaders
this
in
project.
The permanent facade access industry. And a project we are particularly proud of is the Burj Khalifa. We accepted the challenge to design, manufacture and install an integrated building maintenance solution to keep the world's tallest building looking immaculate. By deploying 18 building maintenance units, all of them bespoke at different levels, we overcame a range of architectural challenges and achieved full facade access to this iconic building. The systems deployed range from simple davits to large telescopic knuckle machines and horizontally tracked luffing units. and can descend the cradle 436 meters for facade maintenance such as cleaning and glass window replacement. The rest of the building had no available terrace or roof area, so we designed carousel-mounted units that are garaged into the side of the building. Doors open to allow the BMUs to emerge and track horizontally around the outside on stainless steel monorails, enabling effortless running and reach around the Burj Khalifa's multiple contours. These BMUs are very versatile, with the capability to luff and extend the jib to an impressive distance. The crossbar opens out into a butterfly wing configuration, which allows the cradle to access the building facade directly under the BMU. Safety is our #1 priority at CoxGomil. As the cradle descends, the crews lock into the building using the restraint system, allowing for safe and smooth travel up and down the facade. Operating in 20 countries around the world, CoxGomil provide full end-to-end facade access solutions for the most challenging architectural structures in the world.
Okay, so very quickly, we have done quite a number of projects in Saudi Arabia. You'll see here in the commercial sector or segment, KAFD parcels. We have done quite a lot of projects in the past years. Kingdom Tower is another example. SAP headquarters, we've also successfully delivered the machines for this project, Muraba and so on. Another segment would be hospitals. We've done quite a number of projects within Jeddah itself and Riyadh. Okay, another couple of examples, schools, etc. So, why do we need facade access? This is a very fundamental question we need to answer. Obviously, I think facade elements have a lifespan to itself. You need to be able to access the systems or to replace elements over time. Therefore, you need a safe, reliable solution to access the exterior of the building. Obviously, also to do cleaning. We are in an environment in the Middle East. Buildings get dirty very quickly. There's also special applications, like you see on the third picture, the red building. It's actually used not to clean the building, but to maintain plants. So even LED lightings are also becoming very, very popular these days. Okay, here is a very quick overview of all the systems that we have in the market today available, from the least complex to the more complicated machines on the right. Short buildings, often they make use of simple low-profile davits, up to 40 meters of building height. And if we go a bit taller, up to about 100 or 120 meters tall, we make use of high-profile davits. Okay, for more permanent solutions, we make use of building maintenance units that you see on the right-hand side. When you have special arrangements like positive inclined slopes or negative inclined facades, etc. So in terms of building maintainability, here's a very interesting overview. You will see that as we move from the left to the right, the more permanent solution of a BMU is that it provides better maintainability of a building. Yeah? It can reach much taller drop heights. It can reach further outreach, and so on and so forth. Then we talk about the TCO, total cost of ownership. No doubt, yes, a BMU initially can cost a bit more than monorail davits or rope access solutions, but we understand that labor cost is never constant. Labor costs will always increase over time. If we talk about some developed countries in Europe or in North America, for example, labor is extremely expensive. So over a period of time, we've done a lot of studies on this, up to 2 years. You start to see that the labor cost will spiral upwards. And it's actually a lot more cost efficient to have a building maintenance unit installed. We have examples where a building has had a BMU installed 59 years ago. And by the way, this machine is still working as of today. The client approached us to look into modernizing the BMU along with the rest of the buildings. We've done a lot of upgradation on the motors, drum hoists, the fundamentals. And actually, with what we've done so far, we have prolonged and extended the life of the BMU by an extra 30 years. So this is a very important phase which of the building cycle, actually. Yeah. Okay, digitalization. So in the old days, whenever you have a problem, you make a phone call and someone will come to you to attend to your problems, yes? But in today's day and age, we make use of IoT, Internet of Things. All our machines are capable and ready today to be remotely accessed via the internet or any data connection. Instead of going to the site and coming back, to find parts and all that, we are now capable of looking at the problem remotely and doing remote troubleshooting. We are able to perform software upgrades, just like your Teslas today. We are able to visualize data, study the data, and propose solutions to enhance the system. And we start talking about the next generation of facade access systems. How do we combine and make sure that, how do we make sure that we are moving along with times? We look at combining mechanical, electromechanical systems and IT systems to build the next kind of BMUs. Yeah. So by combining what you see on the left and the right, we come up with a new solution, a knuckle system, which actually has electrical control. Here's a very quick example. If you see on the right-hand side, this is an old conventional system where it has multiple range of motions, and it takes quite a bit of effort. This is what you see currently in today's solutions. But the system on the left is making use of electromechanical solution to perform a linear motion. So this actually enhances safety. It's a one-step operation. And how do we make sure that all these controls are working perfectly fine? We make use of encoder technology, which is actually not present in a lot of other brands today. This allows for high-speed communication between the encoders as well as the rest of the BMU and the PLC systems. So we're talking in a range of like 800 times per second communication. So what happens if someone damages part of the machine? What it does immediately is to send a stop signal back to the PLC, and it prevents the safety device from being bypassed. So this is actually a higher level of safety compared to normal limit switches. Yeah. So with that, yeah, I finished my part of the presentation. Thank you very much.
Thank you very much, Mr. Kelvin. So this aspect of facade design is as important as all the rest, but it's not very known, so thank you very much for that. Now for the next speaker, football fans. Any football fans here? Lots of football fans. It's Jeddah, it's an Arab country, we all love football. The next speaker is a designer of your favorite stadiums, and he is designing the stadium at Jeddah Central. So please welcome from GMP all the way from Berlin, Mr. Markus Pfisterer.
Hello. Well, I think it's very smart to have me before the break, to have a bit of nice pictures, and we can talk about stadiums and soccer and facades. And I'm trying to be very short and compact because I want you all to go with all the speakers to the lunchtime. So GMP is a office internationally operated since 55 years. We have architects only 500 around the world, Germany and Asia mainly. And it's not about promoting our office. I'm bringing you a bit of, let's say, a kind of little lecture about stadium facades in the past. And then, of course, I have examples from our office where we are working on to show some examples. And I'm very happy how always this conference of Zak are mixing some technical details. We heard about, facade engineering. So I'm happy to focus only on architectural approach of stadium facades, because a lot of other technical things you have learned and heard already. And for us as architects, it's always very interesting to hear as well what's happening technically. So you see a very old stadium, which is a part of a city, and you see how the facade actually looks like a building facade at that time. Some years later, this is our Berlin Olympic Stadium. You see that's still this kind of massive stone facade was part of the understanding for a stadium. But again, a German example, Olympic Games 1972 from Frei Otto and Günter Behnisch. This is an old picture, but it still looks today. It seemed that the stadium didn't need at all a facade. So you were looking at the backside of the tier construction, and let's say the whole focus was on the roof, which of course always is mentioned as the fifth facade. It went down, and I think it's a fantastic stadium, of course, freshly renovated. But obviously the approach was not so much anymore on the facade. And this, again, 1980, and we come to that stadium a bit later on, is the Bernabeu, the old Bernabeu from the last, let's say, renovation from 1980. And again, the facade, what you would call, is mainly the concrete construction supporting the roof. There's a bit of circulation going down. These are little staircases, and what you see here are mainly all the columns. So it has a certain beauty, but it is now 50 years ago. So we see a development of the section of this Roman stadium where we have a typical house facade, let's say. Then there was a period with no facade. And now we are looking at something which we called a space-creating facade, where at the, let's say, there's a backside of the construction for the tiers. And obviously architects and engineers start to create a extra layer for a stadium facade to create spaces. So what I brought actually are, I think, 5 or 6 different stadium facades which really focus on very, very different ways of the facade. So this is a stadium in Russia. This is the Baku Crystal Hall. We go in a bit in detail. I just wanted to give you an overview. National Stadium in Warsaw, a sports center in China, and of course at the end the new Bernabeu in Madrid. So starting with the stadium in Krasnodar, who got some prizes, I want to show you an early drawing that for us as architects and facade, let's say focusing on the exterior of a stadium is important. You know, what you promise actually the client, normally you have to actually deliver. So this stadium actually has a quite nice park around it, which we are designing as well. And this, you see how it works like a house facade. It's natural stone cladded. It's very classical in a way. It works nice with the light design in the evening. But if you look at the section here, you see similar to what we seen before. It has this kind of vertical column, but it creates a space even between the first layer of facade and the second layer of the interior. So there's quite nice space between facade and stadium. But for this stadium, and I think this is quite important, if you go very traditional at the outside, you might want to have a more advanced and modern facade at the inside. There's a lot of talking about 360 degree LED screens in stadiums, and here we integrated in the backside of the tier a full LED screen, which operates quite nicely. It blends together with the architecture, so it's not a touched screen, it's an integrated LED screen as a part of the facade. And to do this, of course, in, let's say, time and budget, we had to have certain areas with a high density of LED dots, and then when it goes to this area, it starts to blend out slightly without actually being really noticeable at the end. So if you see now the result, the facade really starts, or the LED screen really starts to be a very integrated part of the architecture, of the interior facade. And I think it shows nicely that a very modern LED facade inside and a very traditional, classical looking natural stone facade outside can nicely work together. I skip it here and let's go to the next example. That's the Crystal Hall in Baku, just to give you an idea of the location. So they have a very nice Corniche area here in Baku, it's in Azerbaijan. It used to be a military harbor. They have a big flagpole here, and this part was then being used for this stadium. Again, there was a very brief design and construction time, actually, less than 1 year. So design and construction was performed in 1 year because it is a Eurovision Song Contest. The country won the contest in 1 year, and the next year they are able to host it. So we, as a consultant directly working for a contractor, had to design a stadium and a stadium facade which is able to be built in 1 year, designed and built, and which has, of course, a certain effect at night time. And if you look at the result now, it is quite close to what we have promised. And we heard about PVC membrane material before. This stadium is constructed in a very similar way. It has a thermal facade. This is the red facade because it's more or less an indoor arena, and as a shading and access giving element, this kind of translucent membrane facade was constructed around it. And you see, like this very simple lightweight material is creating in this kind of spanned way a very, very elegant, very translucent facade, which is very transparent from inside, very reflecting from outside. And with this kind of LED light, you can imagine that this, of course, is creating a very unsharp image. But at the end, we were able to achieve a quite nice facade that changes very much the appearance during day and night time. So this is something for stadium facades which are very important because the volume of the stadium is, of course, quite big always. And there was a bit of a light show attached to it, which goes quite nice together with the geometry of the facade. The next example I want to show is the National Stadium in Poland. And we are talking about stadium facades, about the identity, about the reason why stadiums need now a facade. And if you're doing a stadium at the end, the client is able to do a very simple stamp, let's say, to use this kind of view from the stadium outside. I think it was a quite successful approach. A bit of the story, and we heard about renovation of building and continuing buildings, that you don't have to build stadiums always new. We are very happy as well with this project that there was an existing let's say, field and track stadium without a roof, without even a lot of indoor areas. But in the competition, we were able to convince the client to do the new stadium not next to it, because it was planned to do somewhere here, but to rather use the old location. So the new stadium really sits on top of the old stadium, and it was executed quite nicely. The idea, of course, of this facade was a bit like the waving, again, out of a translucent aluminum stretched metal sheet, which has quite interesting different levels of transparencies. So when you look at, when you turn it 180 degrees around, it starts to be more massive, and we are using only, let's say, the two colors, white and red are the Polish national colors. Of the national flag. So the facade starts to be the identity, of course, of the national colors of Poland. And here in a very early sketch, we showed already how the light can be integrated, and finally is integrated always behind this main structural elements. So this dynamic light was precisely achieved and is operating like this on this facade. And again, these are, the stadium was opened in 2012, so the 3D tools were not that developed as today, but we were very keen on testing very carefully the different kind of facade colors and facade transparencies in these 3D models. What we think is very important as well, on the left side you see the computer testing, very precise 3D model, and on the right side it was the first mock-up to be tested at day and night time, because the translucent effects of this quite simple, as I mentioned, stretched metal aluminum plates have been tested on site, and we were quite happy about the final results, because again you see a bit of the old stadium that you saw at the very beginning. We were able to preserve this old entrance. It was the old hill, and on top of it the new stadium is located, and of course it has a quite nice, I show a bit later as well, a quite nice glass facade, thermal glass facade, as a first layer. And then the second facade is this translucent metal mesh facade, and in the space between is all the circulation integrated of the stadium. We are doing big-scaled models to find out how it really looks, so we don't only trust the computer modeling. And this is the space which I talked about, that this kind of facade needs a quality from outside, but it has to be visible, and it has to be, a spatial quality from the inside as well. Well, stadiums do have a second type of facade. This is the VIP boxes on different level. And of course, this kind of facade has the main idea of being as transparent, as big as possible, to give a clear view to the pitch. We hear about Seele, about really long glasses, curved glasses. If you do stadiums for a UEFA or FIFA event, the client and the consultants are under a huge time and cost pressure normally. So you're ending up with a probably slightly smaller solution that might be possible, because there's just too big time and cost pressure. FIFA and UEFA, if they have their event, they don't move your event because your stadium is not ready. So you have to be very careful about the size of glasses that you are using. Now, this is the stadium which I want to explain a bit about mock-ups. There have been a lot of mock-ups, These are actually different stadiums on one big campus. And you see again the differentiation between night and day. This is something we are very much looking into that. That is an early competition 3D drawing. And again, here it's a bit similar like the Baku project. So we are working on this diamond-shaped facades and constructions where the vertical facade, let's say, goes into the roof construction as well. So it's an outdoor stadium, an indoor stadium, and a swimming stadium all integrated in a big park. The result was very close to what we have designed. In China, we always cooperate with local design institutes regarding the final design phase for issued for construction drawings. So all the phases before are done in our Berlin or in our China offices, and then in the execution we are cooperating with the local partners. And you see how nice, let's say, these kind of similar stadiums with one unique facade look are creating this space around in nature and at night. Now, this project really needed a lot of client discussions to make sure that the client and the contractor then really understands and are happy to learn how these quite complex looking geometries are working. So for the steel construction, they really did in China 1 to 10 model. So it's 10 times smaller than reality, just to double check how the structure looks like. Then they used it to test the inner membrane, again in a 1 to 10 model. Yeah, you don't bring it into this room, it's way too big, but it was constructed on site to test the different materials, to test the different details. So they did the glass cladding as well. And with this model, it was this so-called mock-up pavilion, the effect of light and all the detailing were just tested if everything in our drawings would convince the client to really spend time and effort to do that then in real scale. Well, we talked already about this way of multi-layered stadium facades. So here as well, you see the main construction and section and the tier. And this is the facade that is then connected to the roof construction. And regarding the, together with the engineers, this double level of glass, outer glass and inner membrane creates this skin which is used to get air ventilation around the stadium and to protect the inner stadium to the big amount of sun and heat impact from around. And then finally, these are mock-up models of different contractors before they were assigned the job. The client with us as doing the site, part of the site supervision, to make sure that the quality, what the contractor is proposing in real scale then had to be tested. And well, you saw the result, wrong direction, I'm sorry. You saw the results already before. We just want to make sure that the effort and the time to select and to test mock-ups sometimes have to be quite big to come up with a good solution. So next project is the new Bernabeu. We showed already some pictures before. Again, just to give the idea of the location. The stadium used to be outside the city, so it was a big area around the stadium. I'll show you some historic picture in a minute, but nowadays it's really integrated very much in the city. and basically there's no space for all the 80, 90,000 spectators going in and outside the stadium. So there's basically this plaza. They have to block all the streets here to allow then a certain pedestrian area. And you will see later on that this area, which is a 1 level or 1.5 level retail old shopping mall, could be demolished, let's say. So now in the redevelopment of the stadium, we have a bigger plaza area here as well. And all this indoor area is now combined and, let's say, squeezed next to the stadium. This again is a development, and you see 1954, the first part of the stadium was already constructed, and all these columns are still inside the stadium. So this is still, this layer of history of that stadium is still there. So in 1982, it already got an extension. So you see bigger columns. They added one tier. They added a partial roof. And even in this area, there's a upper tier without a roof. So it was a further development. And in 2002, and this is basically what you saw at the picture before. These are the towers for circulation. So ramps to go down. These are the little stairs. This is a kind of concrete column that supports this roof, and they actually in 2000 did a partial extension for a tier with a new metal mesh facade in 2000. But you see that this image is creating a very how should I say a facade that is built out of different elements, is not one unique stadium, is not the strong image that obviously the client wanted to have. So there was a competition some, let's say, 10 years ago, and probably just as an example, you know, this from, sorry, I have to learn it here. This is a German Reichstag, and there was an artist, Christo, that wrapped it for a while. So the identity of this building was for, I think, some couple of months totally changed by wrapping it, giving it a new identity. There was a huge party during that period, and then of course the wrapping went down, and the building was renovated and is now the German Reichstag. So in a similar way, actually, we approached the stadium to come up with, let's say, a new line around it. And well, here's some models as well, but to wrap the whole, let's say, old stadium, which all the tiers and all the construction supposed to stay there, but to find a new shape that is maximizing, let's say, the size of the stadium, but keeping this new plaza free. And here as well, you see that the let's say the facade, I will go in detail a bit now, wraps all the way up to the roof as well. So Florentino Perez, as the president of Real Madrid, is very much involved in this project since all these years now that we are working on it. And you see a section here where actually the old roof, this is all the existing tiers here, and you see here the old roof, and this is the shape of the new roof, creating additional space for the museum, for restaurant areas. The same thing here, old roof here, which was demolished and being replaced by new roof and new facade out of here to create this very compact additional space inside the stadium, to give more public space around it. This is a section as well where it is shown how all the existing columns that you have seen are actually extended, plus the new steel roof, plus this louver facade, which are metal louver. We were designing them for a couple of years out of aluminum, but the client was very strongly connected to a stainless steel producer. So at the end, he insisted on stainless steel, which sounds quite nice as well to have a stainless steel facade, but we think aluminum would have been a good solution as well. Here are some 3D models that we developed for the early phases of the project, where you could already see that the existing roof have been partially demolished here. We were adding then one more tier in one area where we are creating a bit more space. And you see here how the existing construction are extended and lightweight steel roof, which unfortunately the contractor then did a bit change for whatever reason. I'm not not even allowed to talk about too much. But what you see is how the facade changed the very vertical concrete appearance of the stadium to a very dynamic, more horizontal approach, which of course the client wanted to have a new identity, a new stadium at the old location. Here, of course, you see all the additional functions that are now integrated: a new museum, a new VIP area, new kitchens are integrated in this part of the stadium. Here, where the street is located, there was no centimeter space to do additional. And similar to this art piece at the German Reichstag, these louvers are wrapping the whole stadium, including actually the roof. So again, going back to this quite monstrous vertical concrete facade, if you want to call it a facade, we now looked at all the design work that was done a couple of years ago. Again, here as well, there is video mapping, very nicely developed now. So this facade out of stainless steel louvers are able to show images which are projected by big poles which are under construction now to give ideas about the game to the outside of the people as well. And I think this rooftop terrace was a quite important feature as well for the client, to allow a big tour around the stadium to connect, of course, to the city around. And this is a construction picture probably half a year ago or beginning of the year. We've been there, and you see how the existing stadium and new circulation is integrated. There's a quite a delicate steel construction, and then the louvers, the stainless steel louvers, are still wrapped into pieces here and then bending all around. And there are some elements that are very open to allow air ventilation, to allow light going in, and some other elements are very close because the client didn't want to see much of his existing stadium anymore. So this is a bit newer picture where you can see how the overall shape is very close to what we have promised. So here are the towers actually now wrapped in a darker facade element as well. There are new glass elements on ground floor. These elements, of course, are still open to get materials in and out. So here are the louvers missing. And very honestly, when we started the project, we thought that this is quite crazy to have each element being different, 3D bended than all the others. But the engineering that we did with our engineers, and then the contractor cooperated with Amro to do the execution, they were quite successful and similar that we have seen the stainless steel tubes with Seele. Each element had to be manufactured, had to be named, and then being built in a specific location. If you go to the Madrid, the quality and the surface and the preciseness is very nice, very astonishing. The stainless steel material gives a very nice color to the stadium. It reflects very much the colors and the light from the surrounding. It has a quite interesting interior, so leaving certain lights inside. The client is now filling up the space with his commercial areas like the museum and other areas. And again, these are not professional pictures yet because it's still under construction, but at the end of the year, this stadium will be finished, and I think it's worth visiting it. So I'm very sharp in time, fantastic. So we have seen something in Russia, Azerbaijan, Poland, China, and Spain. And it's very confidential, but this is already in the internet. So since 1.5 years, we are designing together with Khatib and Alami on this new Jeddah Central Stadium. And this will be a stadium of a quite new type because it connects with the master plan of the city. So it's not a standalone object as what you have seen in Madrid, where you have kind of huge abstract piece of stadium sitting in the city. But this kind of stadium is very much connecting with the surrounding, with the small scale of the building. So we are designing all this, let's say, smaller buildings with smaller 2-3 level facades, which are then nicely merging into this rectangular stadium. So I think Jeddah will have a very special facade, a very special stadium, which is not a copy of anything what you have seen in the past. So let's go for lunch, and I'm happy to talk to you during lunchtime.
Thank you, Markus. Let's go for lunch indeed. We have about 50 minutes for lunch break. The prayer rooms are on my right here, all the way down the hallway to the left, so it's a bit of a walk. 50 minutes for lunch break, and then let's reconvene. I hope you enjoyed this lunch and you got back your energy from these intensive talks. Starting this last session, we have our speaker who is an experienced mind in the facade business in the region, CEO of a company called IBECE Energy and IBECE Facades. Please give a warm round of applause, extra warm, for Mr. Osama Abbas from IBECE.
Good evening, ladies and gentlemen. My name is Osama Abbas. I'm the CEO of IBECE Group. And I'm pleased to stand here before you today in front of friends, colleagues, and peers to discuss energy efficiency in facades. I would like to thank Zak World of Façades for organizing this event, inviting us to Jeddah, and always delivering this high quality type of conferences in the facade industry. Okay, so let's get to it. This presentation is divided into the following sections. We're going to talk a little bit about IBECE Group, talk about what's IBECE all about. Going to talk about the Saudi vision for the 2030 in terms of energy efficiency, some facts on Saudi Arabia and regarding the energy consumption profiles as well as energy efficiency. Going to talk about the thermodynamic relationship between the built environment from inside and the external environment, and how does the facade plays a role as a thermodynamic medium between them. We're going to talk about FESPA, which is a special assessment provided by IBECE team, and the chain reaction that results from that analysis. Finally, we go into a project, a flagship project from SABIC, in which IBECE has provided a battery of services in relation to the building skin and the energy efficiency. Yeah. So we are IBECE Group. We basically we are a specialist engineering company in terms of facades and energy. So we provide facade engineering solutions as well as turnkey solutions when it comes to saving energy for the facades. We have 3 branches, and currently in KSA in 2023, operating our offices in 2024, a couple of months from now, based in Dubai as well and in Beirut, Lebanon. Okay, so a quick overview on IBECE Facades. We offer engineering and consultancy, facade coding and parametric modeling, BIM LOD 300-500, facade access and maintenance strategies, facade physics, solar gain analysis, thermal modeling, acoustic assessments. And we also provide quality assurance and supervision as a third-party inspector. We also provide specialist application engineering, for example, cold bent glazing and blast-resistant facades. IBEC Energy, on the other hand, complements IBEC Facades in terms of talking the same language, but in terms of energy efficiency. So we talk about how to save energy, so energy saving services, the FESPA, which is the Facade Energy Saving Potential Assessment, energy modeling and simulation, value engineering, BIM modeling, and the energy measurement and verification services in which we are verifying and measuring the parameters of the facade on site. Okay, so this slide is not about facades, it's about the climate, it's about the global warming. Now, we have all been impacted by the climate change, and climate change now is a fact in front of us, and we cannot help but deal with it. 2023 was a very big year in terms of talking about climate change, a very unfortunate year. For example, we have 23 separate cases of climate change in terms of like natural disasters, in which we have faced, for example, the US has spent over $23 billion dealing with the aftermath of these floods and tornadoes and whatever you want to call them. And in Libya, we had more than 5,000 presumed dead and over $7 billion also of damage to the infrastructure. Okay, and 2023 also marks, the highest average temperature of the Earth. That was in 6th July. Does anybody know what the temperature was? It was, anyone? It was 17.08 degrees. So the average Earth temperature is the highest as recorded to be the average around the globe. And that clearly shows that the planet and the countries are struggling to actually do something about it. And the question is, how does this relate to facades? Because here we're into a facade engineering conference. So how does the climate, how do building envelopes, can the facades do something about climate change? Okay. Now we move into the Saudi vision. The Saudi vision, KSA has a very ambitious plan, basically formed of 6 points. It's called the Saudi Vision 2030. One of the most prominent ones is to have 50% renewables by 2030. Also in 2030, to have 20% reduction in the energy consumption, okay, and to basically achieve net zero in the 2060. Now, achieving net zero means that a building actually neither produces carbon, okay, neither uses carbon. So it's basically all the building in itself by its products is net zero. So pretty much an ambitious plan from KSA in 2030. But it's very good, but let's look at the current facts. Where are we now? Because that's also very important. Okay, right now, the KSA per capita energy consumption is higher, 3 times higher than the world average. And we are, every year, we are increasing in the expenditure trend 5 to 8%. So as you can see now, we are almost at 300 terawatt hour per year. And if we are actually trying to build more buildings and the trend is increasing, the energy expenditure trend is increasing, this means that, you know, this margin will get bigger and bigger. Here we talk about how is the KSA sector divided. It's obvious that 47%, it's 47% in the residential sector, and in total we have around 80% in buildings being consumed, with 79% of it coming from air conditioning. So when we have a building, 79% of the electric consumption in the building is basically going into air conditioning. Again, what has this to do with facades? And this is the slide that we're gonna be talking about in a couple of seconds. Now, does the Saudi team knows this? Yes, they know this. They have CAPSARC. CAPSARC is short for King Abdullah Petroleum Studies and Research Center, and they have issued warnings saying that now 70% of the residential sector do not have any thermal insulation. They said that if you use energy efficiency programs, you can save up to 27% in each building in order to drop down CO2 emissions. And since you have a 4% anticipated growth rate from 2023 till 2026, it means that the gap is going to get bigger and bigger. So we better start insulating now. And it says also that facades are configurations are responsible for 45% of the building's cooling load. So if you have a bad facade, a bad performing facade, if you have a facade that's poorly insulated, then actually you are consuming much more cooling loads than you should be. So what are we trying to cool? Okay, so the HVAC system is trying to cool, the heat coming from the sun, direct solar radiation. We have conductive gains, okay, coming from the U value of the skin. We have hot air infiltration from the air leakage. We also have electric lightings. We have occupants. We have computer. Okay, and as you can see, the facade has 79% because of the convection, conduction, and transmission elements that are actually asking the HVAC system to put more work in order to cool the room. Now, here we talk about the first law of thermodynamics from Einstein. He said something which is up till this point in time still very true. Energy cannot be created or destroyed. It can only be changed from one form to another. So the heat of the sun and the internal environment are in always exchange state. So we cool the rooms. The rooms are extremely cold, and the external air outside is extremely hot, and they are always trying to exchange this heat. And the facade in this energy balance cycle is basically the energy exchange medium. So if the facade is performing well, it will regulate the energy expenditure through this medium, okay? By the principles of transmission, conduction, and convection. Now this is a energy inefficient facade. This is an energy efficient facade. As you can see that once you have an energy efficient facade, okay, it's a much different equation. Number one, the poorly facade, it accelerates the energy balance. And in other words, okay, it does not regulate. So the heat comes in, gets out quickly. Whereas if you have it very much insulated, then it will basically delay the energy balance. It will create thermal discomfort versus enhanced thermal discomfort, increase CO2 emissions, reduce CO2 emissions, increase HVAC equipment cost capex. On the other hand, decrease HVAC equipment cost capex, increase energy bills, and reduce energy bills. So as you can see, there is like a myriad of good points from insulating facades. This is FESPA. I'm going to say it in Arabic so that Arabic-speaking people also can get it. FESPA is the Energy Saving Potential Assessment. It's been created by IBECE. It's a module, a team of certified energy managers that go to site with the specificity, basically, to understand more about the parameters of the facade. What's this facade made of, and how energy efficient is this facade? In Arabic, it's called تقييم إمكانية توفير الطاقة للواجهات الخارجية. بالعربي يعني it's a method, طريقة بننزل فيها السايت so that بنجمع تفاصيل عن الواجهات بتساعد على تقييم الواجهة حراريا. So FESPA, as we would like to call it in IBECE, basically reads these 6 parameters. We read air infiltration, exfiltration rates, قديش هواء بفوت ويطلع عبر الواجهات, relative humidity ratios, الرطوبة, thermography, تصوير حراري, solar radiation metering. So basically we know how much watt per meter square is incident on these facades. We also take ambient and surface temperature readings, حرارة داخل جوا المبنى, U value metering, not just U value calculations, but rather than U value metering. So we monitor across the day and across the nights even what's the U value, and we analyze the glazing composition. Okay. From that, we can basically map the project. We understand basically where the project is. From the 6 criteria, we actually can, this is the optimal range in green, and this is the critical range for each of the air leakage, heat transfer, RH, temperature gradient, and solar energy rejection of the facade. And we basically map the project. So your project in this scenario is here, and then here, and then here, and then here, and then here. It's like a KPI for the facade. And the deliverables of the FESPA, we tell you how much energy savings you will be doing per year. We tell you what are the CO2 emissions savings, which also reflects on the company's like profile or any kind of sustainability scheme they have or agenda. Monetary savings, actual money saved in the bank because of the actual reduction in energy bills over months and months. Investment required and a simple payback period. So every CFO knows that the project will not fly until the simple payback is calculated to be a certain good number in terms of years. Okay. This is another slide talking about retrofits. Okay, it's an example of a building who has an inefficient facade, say, of single glazing, non-thermally broken systems, spending around 654,000 kilowatt hours per year. And then as we go to do retrofits of the facade, okay, like we go back to the slide from CAPSARC, you remember, they told, around 70% of the buildings in Saudi are basically non-insulated. So if we start insulating, as you can see, the number goes from 654,000 to 570,000, 510,000, 450,000. I think in Saudi Arabia, it's like 30 fills per kilowatt hour. So if you just do the differences, you will see that you are basically at the end, you are reducing around 31% in the HVAC consumption, CO2 emissions, and energy bills. This is a chain reaction we talk about because we started the presentation talking about climate change. And we said, what does climate change has to do with facades? We're the facade engineering conference, and Osama and IBECE are talking about, climate change. So we say high energy efficiency facade will lead to less cooling demand. Less cooling demand will lead to smaller HVAC equipment. Smaller HVAC equipment will lead to less energy consumptions, and honestly, for the less renewables capacity needed, the less is so less. Yeah. So everybody runs to put photovoltaics on the top of the buildings, etc. But what you need to do actually is to also manage the existing state. So if the facade is leaking air, has a very high U value, has so much solar transmission, at the end of the day, are you guys hearing me well? I think every time I just, you hearing me well? So if the facade is leaking energy, why would you want to put more photovoltaics on the top of the building? To get more energy so that it leaks out. You need to manage and air seal and make the facades more energy efficient. And you don't have even to pay for this renewables. And if you needed them, then you can just apply them and use them later at a different stage of the project or for a different need. So less renewables means, also we have net zero emissions. And net zero emissions basically is the mission of the bigger vision, which is the climate change, being addressed. Here we're going to go into SABIC. SABIC is one of the projects that we have offered so many services for. This thing is not comfortable. SABIC is a flagship project. I think the doctor, forgot his name, Dr. Hassan, yes, he mentioned something about SABIC, which is the old headquarters of SABIC. This is the new headquarters of SABIC. So it's the project in Jubail. Client was the Saudi Basic Industries Corporation, which is a very famous company here in KSA. Architect was Henning Larsen Architects, structural engineer Thornton Tomasetti. IBECE Group was the facade engineer, main contractor Shapurji Palonji, facade contractor Reem Emirates, KSA, and it was in Jubail. A huge building, guys. It was main building, auditorium, sports center, parking and data center buildings. Over 280,000 square meters of built-up area, and facade built-up area design build was 85,000 square meters. So one of the biggest jobs, really. And the facade buildup was, as you can see here the car parks and the auditoriums and the sports center and the main building. And as you can see, the buildup basically it's a unitized curtain wall system with a catwalk and a GRC sunshade. And what's more relevant here was that the fixings of the catwalks. Now, the project phases, we had a concept stage design, which then went into direct value engineering with the contractor directly. And after that, it went into execution stage. So we provided services at the pre-execution stage and at the intra-execution stage, and throughout the execution. For the pre-execution services, we talked about value engineering and how to achieve LEED Gold and how to analyze the effects of the value engineering from glare analysis to benchmarking the energy performance, IFC versus value engineering, energy modeling, and solar gain analysis. And for the intra-execution, we provided acoustic assessments, thermal calculations and condensation risk, structure calculations, facade development. We also had a chunk of the building being done as a blast-proof facade, which was the podium and 2 floors, PMU and VMU, BIM, etc. In that order. So these are some of the photos of the job under execution at that point in time. By the way, the job was inaugurated in November 2022, last year. So now it's up and running, and it's the main headquarters of SABIC there. So this is the VMU at that point in time. The PMU done some extensive testing on the sunshade and some drop tests for the safety of the glass and impact tests on the inclined glass to outside. Some work on BIM, on the size of the building in BIM. We had some interesting geometries as well with the twisting of the system. Now, when we go about the blast proof, you can see the positive phase and negative phase and how we have customized the system, unitized system, so it can take the blast load. Now, the problem starts with when the heavy GRC sunshade, basically, it requires a heavy steel construction, and the heavy steel construction requires a penetration in the facade. Okay, and after that, there's a fixing on the superstructure. This has created a design challenges. Number one, differential movement concerns with the beam and the glass, thermal bridges, high condensation risk for that area, thermal discomfort, energy leaks, increased energy bills, loss of lead points, and increased CO2 emissions. Okay, so our value engineering option was to replace the GRC with GRP material and drop the sunshade thickness from 300 millimeter to 220 millimeter. This has resulted in lightweight construction and allowed us to install the sunshade on the catwalk directly and on the catwalk on the profiles of the aluminum directly as well with thermal breaks. Okay, so this is the final design in which you see now the unitized panels have their catwalks and the brackets installed, and then the GRP goes on the catwalk. This is some of the elements in the BIM modeling for how the design was envisioned and then implemented. Okay, so the problem was, when we are trying to reduce the sunshade from 300 to 220, basically there was concerns on the overheating of the building because the HVAC system may have not been able to take any extra cooling loads. So what we've done is that we've done energy modeling for the full building, and we did first simulation with the building mass with the catwalks, and then building mass with the catwalks with the adjacent buildings. Okay, and this is some of the readings that we've got for each of the benchmarks in terms of kilowatt hour per square meter per each facade. And then we have done a comparison between the VE and the IFC models, and as you can see, the VE option in some facades it's a little bit over the IFC, but in some other cases it is even less. So there was no real concern on the HVAC system, in fact. Also, there was concern on the glare and how does reducing the sunshade from 300 to 220, how will that impact the glare? And we've done analysis for the glare, something called the daylight glare probability, DGP. And after the analysis, you can notice that You have the VE. We have some areas like on level 06. We have some areas where we have some extra glare, but nothing to be alarming. And then if you look at the location of the desk being analyzed at each step of the way. Also, we've been asked from inside, what's the impact? This is the 300 millimeter sunshade, and that's the 220. So from inside, we had better aesthetics. In conclusion, in terms of money, we were able to save 2.5 gigawatt hour per year energy savings, totaling at 645,000 Saudi riyal, at 0.257 Saudi riyal per kilowatt hour. Environmental saving 1,500 tons of CO2 emissions per year. Indoor quality, enhanced thermal comfort, reduced levels of condensation, induced humidity. So there is less of a chance to have humidity inside the rooms and condensation and mold growth. Conclusion, improving energy efficiency in building sector, investing in high-performance facades, retrofitting existing facades will lead us towards the realization of Saudi Vision 2030. Thank you.
Thank you very much, Mr. Osama. Energy efficiency is the name of the game worldwide right now. And even more importantly, the climate change has caused an overheat or an increase in the temperatures that have affected the facades. And so in Dubai, at least, we have seen increase in fires on the facade. And speaking on the topic is the next speaker from one of the leading multidisciplinary consultancies in the region, and he is leading the next generation of fire life and safety. Please give a warm round of applause to Abdullah Faza from ASG.
Assalamu alaikum, masal al-khair. And thank you so much, Amro. That's a big statement to lead the next generation of fire safety. I'm not sure if I'm ready for that yet, but I'm Abdullah Faza. I'm Director of Fire Life Safety in ASG, Middle East. ASG is specialism consultancy services in 4 main offices, Riyadh, Dubai, London, and Singapore. We are 300 consultants and engineers. More than 60 of them are ground-based in Saudi. And today I'm going to talk about facade fire safety for existing buildings, and we will touch base on some of the global best practices. Normally, it's not an easy one to talk about in such innovative discussions about facade technologies, facade materials, sustainability, because we somehow make the life of facade designers and architects difficult. And I can hear some of the architects and facade designers here go like, stop, don't take me through the code compliance discussion. So I'm not going to talk about the requirements in the codes, whether it's SBC or NFA or IBECE. These are clear for everyone to follow. And I believe we are in a better shape today compared to 5 or 6 years ago in this region when it comes to design safe facade systems. But I'm going to focus more on the existing buildings, okay? So to take you through the slides, we will understand the facade fires, what are the challenges, what are the global best practices available, and we will talk about 2 case studies, one in the UK, one in the US, and we'll see what's the difference between both of them. And we will conclude and maybe agree on some future directions. So understanding facade fires and why it's important to keep talking about it. So obviously it comes with risks, and the risk behind facade fire is it can spread rapidly, and we've all seen what happened in the address back in 2016. And it can also spread over multiple internal compartments. So the fire can start externally, but the risk of it can extend all the way internally. And that brings danger to occupants as well as danger to firefighters. What are the contributing factors to that? Number 1 is the combustible cladding in the building or the combustible facade systems. And the poor facade fire safety design, and for example, the lack of cavity barriers or fire stopping within the facade design. And I think the big one in relation to existing buildings that has combustible facade system is the slow reactions or absence of legislations, at least within this region. So what are the challenges? As I said earlier, I think the new technologies and the innovative materials bring a lot of challenges in relation to fire safety. We've noticed that some of the plastic-based insulation materials or plastic exterior panels are somehow back to picture to achieve some architectural needs or thermal comfort. And there is obviously a need of risk assessment, which will come with a question of who is responsible to take the decision on that risk assessment and who is responsible to pay for it, which will bring in a lot of financial constraints and costs and the lack of awareness of what is required to be done for existing buildings. And obviously, if all of this is done and completed and we somehow reach the conclusion of what do we need to do for our existing buildings, there will be a challenge of volume of work required, and the same was experienced in the UK after Grenfell Tower. So, in terms of global best practices, how do other countries deal with this? In a simple way, we can summarize them in 5 main steps. Number 1, the need for assessment of the risk of the existing facade, which will bring in new regulations in place. And then we need to have regular facade inspection and maintenance to identify and rectify potential fire hazards. And moving on to retrofitting non-compliant or hazardous materials with fire resistance materials. And the question will be, who bears the cost? Installing effective fire barriers and insulation systems to prevent fire spread. That's number 4. And the last one is enhancing compartmentation within the building as well as outside the building. So let's talk about what happened in the US as case study number 1. So you can see in the video, there is fire back in 2008 in the Monte Carlo Hotel Casino. And what happened at that fire is the fire was ignited on the rooftop due to welding operations during renovation work. And around 17 people suffered minor injuries due to smoke inhalation. And the fire was under control within few hours. And the hotel remained closed for several months due to repairs and renovations. So when we look at this, it's an unfortunate accident, yet it was controlled somehow safely. There is 0 loss of life, and it took firefighters only a few hours to control the fire. And I think that makes us ask a question. Why? When we look at the other fire incidents around the world. And we believe in the US, because they have adopted an early legislations for their exterior wall systems, example of that is NFA 285, where all exterior wall systems should go in a full test or a full large-scale test, where you literally build the wall built up in that lab and test it for 30 minutes. And I believe that helped somehow to mitigate the risk of exterior wall fires. What changed after that fire? Although it was an unfortunate and it was a bad accident because it's a fire accident after all, but they still took some actions, and one of them is the authorities reviewed and revised the regulations regarding the use of flammable building materials in construction. And some hotels and casinos invested in upgrading their fire suppression system, including sprinklers, smoke detection system, and fire inspections became mandatory on all hotels and hospitality projects. So this is the case study number 1, and let's take the second one, which is, I believe everyone in this room is aware of it. So Grenfell Tower fire 2017. What happened in this accident? So what happened is tragic incident. The fire was ignited by a faulty refrigerator in one of the apartments on the 4th floor. And the reason is simple, normal, and for somehow reported to be one of the most repetitive request to be received by the UK Fire Service on daily basis. The fire rapidly spread through the building's exterior cladding due to flammable materials used in the construction, and 72 people lost their life and more than 70 serious injuries. And it took more than 24 hours for firefighters to put the fire down. So when we look at that and compare it to what happened in the US, it's totally different consequences and results. What changed? Almost everything related to fire and life safety in the UK, either being reviewed, reassessed, or revised. And significant changes in the UK building regulations with a focus on improving fire safety standards, cladding materials, and tenant rights. And I will leave you with this 2 minutes video so you can understand exactly what happened.
A catalogue of safety breaches at Grenfell Tower contributed to the rapid spread of the fire. That's according to experts testifying at the Grenfell Tower inquiry.
I have never seen a building where the whole of it was on fire. Nobody has ever seen that. It was incredible. It was so alien to anything I had ever seen.
The blaze started in flat 16 on the 4th floor of the east elevation. It rapidly spread through the window. The first image of the flames taking hold outside flat 16 was taken at 1:09 a.m. It took just a few minutes for the fire to spread up 19 stories to the top of the building. While the fire was spreading upwards, it was also spreading horizontally at a tremendous rate and in opposite directions until all 4 elevations of the building were engulfed in flames. The flames met at levels 22 and 23 near the southeast corner of the building. In total, 98 flats were exposed to the flames. 72 people lost their lives in the tragedy. The report identified the cladding as the primary cause of the fire spreading up the outside of the building. Tests showed the cladding materials didn't comply with the recommended fire performance for a building of that height. It also claimed the key players involved in the 2016 refurbishment of the tower hadn't found out how the new cladding system would behave in a fire. Other safety breaches were cited for the devastating spread of the flames. The windows lacked fire-resisting cavity barriers and were surrounded by combustible material. That meant there was a high probability of fire spreading to the cladding. Poorly performing fire doors contributed significantly to the spread of smoke and fire to the lobbies. And some doors failed to self-close after an occupant escaped. This allowed immediate spread of fire and smoke. Lastly, firefighters may have contributed to the spread of fire and smoke into the stairwell.
So this is a quick one about what happened in Grenfell, and if we want to just pause for a minute and try to summarize what happened, and I will put some points where I need you guys maybe just move your head, whether you agree or disagree with that summary. So we had the building which was not in a good condition in relation to fire safety, and several concerns were raised by tenants, but no actions, right? And then another one is recent external wall refurbishment took place using combustible exterior wall materials. It was part of the story. Normal flat fire due to electrical appliance fault, and also was mentioned in that video. The fire broke out through an open window, igniting the external panels, then spread up the building to the other flats. It's also part of the video. The fire spread internally as fire doors failed miserably, and people were inhaling smoke while they escaped to the single staircase of the building. And how many people we said lost their life? 72. But the same exact sequence of the story in another building. In this accident, 6 people lost their life. And it was Lakanal House Fire, London, 2009. Just copy-paste from what happened in Grenfell. And this is a picture of the building. And if you want to know more about what happened in Grenfell in terms of story, in terms of all the reasons, especially those related to who is responsible and should we take actions or not, I would recommend that you go and read this book. It says, Show Me the Bodies, How We Let Grenfell Happen by Peter Abbas. So let's pay more attention and focus on the positive side. What's changed after Grenfell fire in the UK? So the positive impact of it, obviously after the inquiry took place, they summarized 3 key findings. Number 1 is the roles and responsibilities of those designing, constructing, and maintaining buildings are unclear. And this is not only fire safety, it's across the disciplines. Number 2, regulations and guidance are ambiguous and inconsistent. And the processes that drive compliance with building safety requirements are weak with poor record keeping. I think we should really ask ourselves, do we have a permit in place for facade fire safety design? Who is really reviewing our design of facade systems in relation to fire safety and details and confirm whether they comply with the local codes, and who is supervising these materials and installation during construction work, and who is certifying them at the operation stage? And I think the answer in most of the countries within this region will be nobody. So if we want to summarize what happened in the UK after Grenfell Tower, we can summarize them into 2 different actions. The number 1 is the enhancement that happened for codes and standards. So update of fire safety guidance, and that happened into 2 main documents. The main one is Approved Document B, Volume 1 and Volume 2, which act as the main guidance of life safety requirements in the UK. An example of one of the changes, it's now banned to use any combustible cladding on buildings over 18 meters in height. That's just an example. And by the way, a lot of people are not happy with this, because are we saying let be buildings less than 18 meters to burn? And the other changes taking place now in BS 9991, and it's now under review. And there are a few changes expected to take place in that code in relation to sprinklers in residential buildings over 11 meters, pressurized staircases regardless, and evacuation lifts and refuge areas, and others as well. So this is one aspect of the impact. The other aspect of the impact that took place in the UK is the assessment of existing buildings, which is what we really need to see in our region one day. So they came up with 2 approaches or 2 methodologies to assess their existing buildings in relation to facade fire safety. The main one and the basic one, called External Wall System 1 Form, EWS 1 Form, was developed by the Royal Institute of Chartered Surveyors jointly with mortgage lenders. And well, interesting fact, because nothing funny about this story, it was driven because of the bankers. So banks were not able to mortgage any of the buildings because owners were not able to justify whether their facade system is safe or not. And insurance companies were not happy to go with any application requests. So money was the drive behind this. But anyhow, we ended up with good result. So the EWS works in four main steps. So the first one is the client or the owner will brief the consultant, who is certified fire engineer on board, with all the building information and what they want to achieve. And the second step will be the certified fire engineer appointed by the owner will review all the drawings, will review all the available information, and try to come up with assessment. And if that's not possible, they move to the third one, which is site inspection to validate or to find more about the building. And the fourth step will be to write the report and come up with, yes, it's safe and it's signed by me as certified fire engineer, or no, it's not and it needs more remedial actions. And the other one, in relation to assessment of existing buildings, is PASS 9980. And this is a decision tree developed by British Standard Institution, and it simply addresses more than facade fire safety in relation to existing buildings. It takes you to a next level to look at the internals of the building and everything in that building, if it's needed, by EWS form. So, what's the conclusion and what's the future direction? We believe, number one, we need to acknowledge there are problems in existing building stock and an urgent solution is needed. And consider global best practices, whether it's in the UK, US, or anywhere else, to come up with our own local or regional best practices. So could the GCC or Saudi implement a similar risk assessment-based approach for existing building facades? Hopefully the answer is yes. The need for collaboration between stakeholders, whether it's local authorities, building owners, facade designers, material industry, and FLS industry as well. Proactive measures are needed as these facades already exist in occupied buildings and pose current risks. Some of them are our buildings, or some of them we don't know about yet. Mitigation measures are needed to help prevent facade fires and protect lives and property. So, as I said in the beginning, it's not the most digestible topic for everyone, especially architects and facade designers, but I think it's worth paying attention to and bring it back to the table and start discussing it again. And in conclusion, I would recommend or encourage you to come back with questions, queries to our key FLS people in the department. Dr. Holly is our director in FLS UK, and she is leading the facade fire safety offering in the UK. Dr. Joanne Knox, our technical director in the Middle East, and Jim Quitter, who is our executive FLS consultant, and he's also the chair NFA Building Code Committee. Thank you so much for listening, and looking forward to see you again.
Thank you so much, Abdullah. That was a really shocking video. You didn't have to do that, but thank you. Now for our next speakers. It's a set of speakers from AGC, AGC Chemicals Europe, and AGC Fire Rated Glass. So that topic will kind of touch on what Abdullah spoke about. So we're having like a bit of a fire section in this conference. And please welcome on stage first, Mr. Ben Runhaar from AGC Chemical Europe.
Hello, thanks for the kind introduction. Yes, my name is Ben Runhaar. I work for AGC Chemicals, the chemical section of AGC. I'm here together with my colleague Rami, who will be talking about fire safety glass. He's also from the glass division, obviously. So the agenda, I will talk a few words about AGC as a company, and then the Lumiflon resin, the Fluon ETFE are my responsibilities, then Pirobel by Rami. So maybe start with AGC. Maybe not everybody knows the company. It's a Japanese multinational company, a turnover roughly 15 billion, and we're with 57,000 people. As you can see, glass division is still the biggest area of our portfolio, and I belong to the chemical side on the far end over there, and then especially to the fluor and specialty chemicals division. Okay, this is the AGC Chemicals division, very complex, don't pay too much attention. The only thing that I want to highlight here is that we are back integrated. So we start all the way from products like fluoride, so which we take from the earth, and raw salt and potassium, but we produce all the way all the raw materials in the chain until we get to the TFE, the circle there in the middle, and from there we can produce the various fluoropolymers that we sell into the market. Lumiflon resins, that's the first product I'm going to talk about. It's a resin, not a final paint. So a resin, however, is very important for a coating system, and it actually determines the quality of the coating. That can be used up to 60% in a coating formulation. The chemical name for Lumiflon is FEVE, fluoroethylene vinyl ether. And we sell these products actually to our paint customers, so the paint companies are our customers. We like to kind of highlight the fact that you can actually label it as Lumiflon inside. That's just why we are asking a lot of attention for these products. It can be used in solvent, powder, and waterborne paint systems. Today I'll touch on two, solvent and on powder. And I'll go a little bit more in detail in the next slides. So why is it so good? It's extremely stable against UV light. The polymer is very stable. It doesn't degrade under UV light. You see here some examples of a bridge which was painted in 1986. Then 30 years later, it still has almost the same color and gloss as the original. So this is why people are using our product, especially here in the Middle East region where the UV radiation is extremely high. This is also what we concentrate on when we talk about our architectural specifications. So we focus on the 10 years Florida. It's covered by Qualicoat Class 3 and AMA 2605 specifications. Gloss retentions and color variations needs to be, gloss retention needs to be above 50% after 10 years in Florida, and the delta E, the color variation, needs to be below 5, which actually means that you don't see a difference on the color. Fluorinated coatings are needed to be able to reach these 10 years of Florida specifications. Of course, we've performed all the tests, accelerated as well as actual outdoor testing. You can see on the right there, this is an actual 10-year test in Florida. So for architectural use, they're actually used in two applications. The coil coating applications, which are flat panels, which can be solid panels, or these so-called ACMs or composite material panels. On the right-hand side, the aluminum extrusions, window frames, curtain walls, they can be coated by either a powder or a liquid coating, and I will touch on that a little bit later more. So on coil coatings, it's a roll-to-roll coating application on aluminum of steel. You see here some rolls. These rolls are actually the rolls that were used for the Ferrari World in Abu Dhabi. And from these coated coils, the producer can make solid plates or ACM panels. Here is an example from one of our loyal customers here, Alpolic and ACM, and for instance, this one has an A1 classification, fire classification. Of course, very important, seen the previous presentation. These are two examples of a solid coil and an ACM. Of course, everybody recognizes the example. Of course, the Ferrari World, now probably 13, 14 years old. Still, of course, a nice red color. This one cannot go pink, as you can imagine. So it's very important that the color stability is good. And the Burj Al Arab, a little over 20 years out now, 23 years. A white ACM panel from Alpolic, still looking very nicely today. When we go to powder coatings, as explained, there are two ways to produce aluminium extrusions. One is by powder, one by liquid spray. I'll concentrate on powder coatings at this moment. You could do, in liquid spray coating, you could also use a Lumiflon spray, but there we mostly run into our competitor PVDF, which is also a fluorinated resin system that can be used for ultra-durable coatings. So when you compare the powder coating Lumiflon to the liquid PVDF, there are some differences. Both, of course, are ultra-durable. However, the powder of Lumiflon can offer a wider gloss range, so we have low to high gloss, while most of the liquid PVDFs are in the middle range gloss level, 30 units of gloss. And the other thing is that for powder coatings, we don't need primers, and for PVDF, you would need a primer. It's a single layer application for powder versus multiple layer applications for a PVDF. No VOCs, of course, because it is a powder coating, and it can be reclaimed. The powder can be reclaimed, again, different to a liquid PVDF. That also impacts, of course, the CO2 emissions. Per square meter of product, you'll see that an FE powder paint will roughly use half of the CO2 or expose half of the CO2 emission versus a liquid PVDF paint. Some product names. There are some colleagues here from Jotun as well. These are products that are using our Lumiflon a resin, the Durasol from Jotun, the Interpons from AkzoNobel, the series 7586 from Tiger, and from Sherwin-Williams, the Echelon collection. Some examples: STC Smart Square here in Riyadh in Saudi, and the coating here was done by Jotun, the Jotun Durasol. Here, two projects here in Jeddah, Al Mohassin Hotel and the Four Seasons Hotel. Both from this year, and again, both were done with the Jotun Durasol. And then the project in Qatar Towers in Qatar, I think another famous example. This one was using the coating from AkzoNobel Interpon, again, using our Lumiflon resins. Then quickly, a few words on ETFE film. We're now on the right-hand top there. We produce both the resin as well as the film. ETFE film, the properties, so it's very lightweight, it's transparent, which means that grass and trees, etc., will grow underneath a product like this. It's extremely durable, 30, 40 years old, no problem. The oldest buildings that we have today are 40 years old. It creates a very nice, comfortable space, meaning that the sound inside the building, especially like here in the Avenues Mall in Kuwait, it's much more quiet underneath an ETFE cushion roof instead of versus a glass, for instance. And of course, you have a lot of design options possible. So where is it used? It's used in sports facilities, for facades as well as roofs. It's used in domes, biodomes. There's a big one being built currently in Riyadh, the King Abdullah Gardens. That one is using an ETFE roof. Again, trees, grass, plants, everything will grow underneath these ETFE film. Shopping centers, of course, here we see the one in Kuwait. The Avenues is quickly building more of these shopping malls, and I will show a few a little bit later. Transport, train, bus stations, and these kind of things. Here are two projects here in Riyadh and in Khobar. Both are Avenues shopping malls, and both will be using ETFE film, in this case done by our customer, which is the fabricator Vector Foiltech. And this is another project in Jabal Mubarak Stadium in Kuwait. The fabricator here is Tayo. This is some schematics, but here on the bottom you see already some of the pictures of the final facade, how it will look. That's it, and then I'll hand it over to my colleague, Rami, and he will talk to you about fire-rated glass.
Good afternoon, ladies and gents. Really, it's a pleasure coming here today to discuss about a very important topic. I thank Mr. Abdullah before. Really, he had highlighted. Thank you very much for highlighting on the fire rating, because really, it's a very important topic. And we are seeing in some places they are not taking it seriously when it comes to fire rated and specifically the compartmentation of the buildings. Let's start watching a very short video. Moving forward.
Pyrabel is AGC's brand of fire-resistant glass. Pyrabel makes living and working environments safer, offering the widest range of fire-resistant glazings on the market. Pyrabel glazings are manufactured at 3 industrial sites, Senef in Belgium and Oloví and Sokolov in the Czech Republic. Our products are distributed via our local distribution network in Europe as well as globally. Pyrabel can be cut on-site by our distributors, meaning they can supply you with what you need quickly and efficiently. For 40 years, we have been supplying sustainable fire-resistant glazing solutions, renowned for their outstanding quality. Our priority is your long-term safety and security. Reducing the environmental impact of our products and processes is one of our main goals, which is why Pyrabel fire-resistant glazings are cradle-to-cradle silver certified. We support our customers with our technical expertise and flexible service. Fire resistance is quantified in European and international standards, which define 3 classes. Class E stands for integrity. This means that the element acts as a barrier to flames and hot gases. Class EW stands for integrity and radiation, which means that the element acts as a barrier to flames and hot gases, while also limiting heat transfer. Class EI stands for integrity and insulation. This means that the element acts as a barrier to flames and hot gases, while also blocking heat transfer. Since Pyrabel is available worldwide, it also complies with American, Russian, and British standards. Approved laboratories conduct fire resistance tests to classify and rate glazing systems. These tests are always performed with the glass in its structure or frame. This element is placed in front of a large furnace and must remain intact for the duration of the test. We perform more than 100 tests per year on our glazing products, including Pyrabel T. Pyrabel T is available in sizes up to 2 meters wide and 4.5 meters high. If the element passes the test, the results are documented in official test reports or certificates, and the glazing solution can then be brought to market. Pyrabel is the most tested and fire-rated glass in today's market, capable of delivering fire resistance up to 180 minutes. With its near-perfect flatness and clear gel, it can barely be distinguished from ordinary laminated glass. Pyrabel fire-resistant glazing can be combined with 1 or more additional functions, including insulation and decoration. But Pyrabel also meets the need for high levels of protection. Our new Pyrabel range features protective products capable of withstanding firearm attacks. Pyrabel glazings are suitable for both indoor and outdoor use in all buildings covered by fire protection regulations, including shopping centers, hospitals, airports, and train and metro stations. In its ongoing quest to pursue innovation and anticipate safety challenges, Pyrabel has fully embraced AGC's Look Beyond vision. We aspire to become your partner of choice in
a very important video in relation about classifying the fire-rated glass into 3 classifications: integrity with limited radiation, which transfers 15 kilowatt per meter square, and integrity and insulation, which is the most advanced fire-rated glass. So we'll pass through these slides. It's already explained in the videos. The most important thing I would like to highlight: at the end of the day, we need to save the people's lives. So we don't want to compromise on fire-rated partition, glasses. This is very important, that we need to save the human beings. And the precautions that we need to take is the compartmentation in the building. How do we contain fire, heat, and smoke? It's very important. Safeguarding people's lives, limiting damage into the buildings, protecting escape routes. I'm realizing that in some of the projects that I'm visiting in the region, because I'm handling GCC region and Egypt, I'm realizing that there is a downgrade from EI, integrity and insulation, to EW and to E, due to the value engineering of the projects and cutting down costs. But they are not looking into the serious scenario, what will happen if, God forbid, fire occurred in a building. So when you downgrade to EW and E glass, this is really dangerous, specifically when we talk on evacuation and escape routes. Stop. It's more than enough. Yeah. We had highlighted a couple of things. Thank you, guys.
Thank you very much, Rami and Ben. Our next speaker, I don't know if he needs an introduction. The next speaker represents Quality Middle East. He's sitting right over there. Please give a warm round of applause to Mr. Khalid Shamlawi, representing QMEA.
Assalamu alaikum. Pleasure being with you here today. صراحة, I can't help but look at my picture. I have a bad small history with Zak. In Egypt, 2019, I was there, okay? And my picture was so bad. Like, literally, my face was much bigger. I was 20 kilos more. And you feel like my face was going to come out at the people, you know? So, it was, you guys think I'm exaggerating, but it was so bad that I went to the one person that would tell me, no matter how bad I looked, you are beautiful. And it was my mother. So I told her, Mom, what do you think of this picture? I'm very nervous about this picture. And she literally said these words in Arabic, La ibni wala ba'arafak. You're not my son and I don't know you. So I'm glad. I mean, I do look like I'm held hostage here, forced to smile, but still, it's much better than last time. So I'm Khalid Shamlawi. I'm Specification Manager at Jotun Powder Coating and Business Development Manager. And I am a QMEA member as well. Today we talk about QualiCoat, which is the standard for powder coating. We will look at, in today's agenda, QMEA, QualiCoat, the standard, benefits of QualiCoat, classes of finishes and how to specify it. An important one we want to look at is seaside application, recommendations for care, how to take care of your coated aluminum, and comparison between QualiCoat and other certification bodies. I'm going to make this very easy, will not get technical at all. The point of this is for you to understand the concept and ask questions later. Not when I'm on stage, obviously, maybe after. What is QMEA? It stands for Quali Middle East Association. It's an international non-profit membership-based organization, registered and licensed by Dubai Chamber of Commerce. QMEA is a representative of QualiCoat, QualiDeco, QualiAnode, and QualiSteel in the Middle East, as you can see, the countries and South Asia. Okay. طبعا, there's this code here. If you want to scan it, that takes you directly to the website where you can find later on the specifications when we talk about how to specify QualiCoat and stuff. Memberships include the following companies. So who does QualiCoat certify? Okay. First of all, powder applicators. Powder applicators are the people who buy the powder from suppliers and spray the powder onto the aluminum, okay? And then powder manufacturers such as AkzoNobel, Jotun, Axalta, Alwan, these different manufacturers. And then you have pre-treatment chemical manufacturers, and you have associate members. Now, what is QualiCoat? 1986, okay? It's been there since 1986. It's headquartered in Zurich. A very easy way to know what QualiCoat is, for me, I like to define it as, if you read QualiCoat, it's quality of coating. So it's the guide to quality of coating. And it really gives you the quality of coating, and it's the way how to apply and the best practices you can do to apply. And of course, like we said, it certifies 3 different players. Again, this is a very easy pyramid square shaped thing here, okay? You have the QualiCoat specification, which is very solid. It's a solid specification. Again, on the website, you can always find the specification. It's very detailed, very descriptive. And then QualiCoat, like we say, we have licensed coaters, approved pre-treatment systems, and approved material coating systems. And then with that, you get a product with the highest quality. Okay, how to specify? You can get in touch with any QMEA member. It's a very easy, that you can reach out to anyone who's a Qualico member. And of course, it's, like I said, the specification is very easy to read, okay? It's very easy to incorporate into your system. And then there's all the maintenance details, everything in a project you may ask for, you may wonder, how is this, how is that? Qualico is always there to help. Benefits of Qualico, it's a global standard for architectural powder coating in any environment, okay? Independent certification, so it's not only about certifying one body, like we said, it's more than one, so it's the whole cycle, okay? Your pre-treatment, your coating, your application, the whole cycle is individually audited, okay? And then simple specifications with traceability of the process and inspections. Of course, quality of the product is checked by the applicator at the end of the process, okay? Qualico always continues to improve, find new things, you know, stay up to date with the market. Of course, they have separate specification for decorative coated aluminum, which is, if you've ever seen wood finish on aluminum, okay? And basically in wood finish, if you guys know what that is, it's, there's actually two processes to it. So there's something called sublimation and there's something called powder on powder. So sublimation basically is we coated the aluminum, we're done, yay, okay? Then the applicators have films, okay? So these films have the nice decorative lines on them. So what happens is you put the film, the air is sucked out, okay? It's put into the oven, it's cured, the ink on the film melts, okay? It forms the shape, it's out of the oven, film is removed, and the ink is now a part of the substrate. So that's a more popular practice of wood finish. And then you have powder on powder. So powder on powder is basically literally powder on powder, but you know, it's like a drum roll effect. So imagine coated surface, so drum, powder is fed into the drum, and then it rolls. So the drum has designs already on it, the lines. So it's rolled onto the substrate to form the lines. So it certifies, so what Qualico does is it has a separate certification which is called QualiDeco, okay? And it certifies the quality of decorations for exterior applications. It verifies quality of powder, decorative films, so the films itself and their combinations together. And verifies the plant, equipment, and the application process. Okay, now, just so we understand how the powder coating process works.
Aluminium profiles that are used in construction projects are coated on horizontal and vertical lines. Vertical lines allow coating of long profiles, and they usually have higher productivity than horizontal lines. Here, we will focus on the coating of aluminium profiles on the vertical line. The process begins with manually loading extruded profiles on the inspection table and checking them for possible defects. Good profiles are then loaded on the coating line with the help of special hooks and undergo several important steps to guarantee a quality coating result. Process parameters of the line are set up and monitored using control panels and specialized software. Chemical pre-treatment involves use of phosphates or chromates in submersion or spray application. These often occur in multiple stages and consist of degreasing, etching, desmutting, various rinses, and the final phosphating or chromating of the substrate. The pre-treatment process both cleans and improves bonding of the powder to the metal with the help of a conversion layer. After pre-treatment, profiles need to be dried in the oven. They will then proceed into an application booth, which in most vertical lines will use specifically adapted electrostatic guns or disc. The guns or disc impart a positive electric charge to the powder, which is then sprayed towards the grounded objects. From the application booth, the profiles move into the curing oven, where the powder is exposed to elevated temperatures, begins to melt, flows, and chemically reacts to form a higher molecular weight polymer in a network-like structure. From the curing oven, profiles travel to the unloading area, where they are manually removed from the
Okay, then basically, in summary, okay, you hang your powder coating material, okay? Pre-treatment is one of the most important things you can do in powder coating. You always do need a proper pre-treatment, because later on, if any of the pre-treatment is not correct, okay, in powder coating, a lot of problems happen later, okay? So pre-treatment is key in any powder coating application line. And so after pre-treatment, it's dried. And pre-treatment, just so you guys understand, it's like you're cleaning the surface basically from anything that's not supposed to be there. Okay, you're cleaning it completely. And then, yeah, it's dried, you powder coat, electrostatic, it's a spray, okay? And then it's cured, it's melted, and then it's ready to go, okay? Now, what I said was this was the most important concept. A lot of people neglect this, but it's become very important, especially in these sort of countries because it's very humid and we have to resist all this very high corrosive environment. And there's something called seaside application, okay? And this is solely to avoid something called filiform corrosion, which we will get into now. Now, quality designation within a Qualicoat, okay? It's designed to meet, like we said, higher corrosion protection requirements in coastal areas, okay? Now, not to get technical again, but you just need to increase the etching rate to 2 grams per meter square. Now, sometimes it might not be in a specification, okay? I've seen a lot of specifications. I'm a specification manager, that's not, that's not new, but you might have to tell when you go to your applicator or you go to a site, you might want to add to the fact that, hey, I need this to be seaside application. You might think it's a complicated thing, but it's actually mainly the etching rate that needs to, and it's something that can be done in the application line. Like we said, harsh environment, coastal area, high risk of adhesion failure, and in some countries, all the coaters are seaside qualified, by the way. Now, approval of powder coating, powder coatings, paint systems are referred and classified into classes, okay? Every system can have a variety of glosses. I'm sure a lot of us know this already. Approvals are granted against performance of classes. Now, the easiest way to learn powder coating, and I tell this to everyone, it's a very easy way. This slide pretty much sums it up, okay? You have 3 classes. The higher you go in class, okay, the higher you go, okay. But the higher you go in class, 1, 2, 3, the higher the weatherability and durability is, okay? So class 1, minimum 60 microns, that's 60 microns, the film thickness, okay? It's the standard durable and 1 year Florida. Now, you guys might see, you're like, what is Florida, okay? So Florida basically is yeah, it's a test, and it's basically the colors are put in a place in Florida. It's known to be one of the most harsh and humid places on the planet, and 1 year in Florida is equal to 3 years in the Middle East. And we thought here is hot, but in this area, we literally, it's tested here because of that harsh environment to see how much it can resist. And as you can see, the higher you go up in class, okay, so standard, super durable, and hyper durable, the higher the resistance of the years in Florida. So yeah, so 3 classes, higher you go, the higher the durability, the higher the performance will be. Gloss levels, I've seen a lot of people define gloss levels differently, to be honest. But how it's as per Qualicoat, so matte, you'd consider a matte from 0 to 30 plus or minus 5, okay? Satin, what you call satin is 31 to 70, plus or minus 7. And glossy would be 71 to 100, and plus or minus 10. Structured finish or textured finish or rough finish, however you like to call it, that's 0 to 30, plus or minus 5. As you can see, there's always a plus or minus, because in powder coating you can't really, you know, control a exact number. Now we said seaside, and why it's important, because you might see, oh, that was fast. So you might see things like that. Actually, I just want you guys to see. You might see things like this. If you have issues like this, probably you didn't have seaside application. So we need to watch out for these kinds of things. So filiform, so the filiform corrosion test I talked about as well. It's a type of corrosion. It looks like a little worm, okay? It's between the metal and the coating, okay? You'd see it's like a little worm, like we saw in the picture before. And then it can occur only under the layer, like we said. So, حاضر والله حرام عليكم كل حدا أخذ وقت. لا, I love you والله. مشكور حبيبي, مشكور والله. خلاص. يعني ساعة بعدك قاعد عادي. ساعتين خلاص. Okay, so basically salt can speed up the filiform corrosion process in up to 5 minutes, okay? And of course you have these testing methods. Again, this is a more complex. You can ask, we have Mark here also from IFO. You can ask questions outside. Still have time. These are the types of failures you can see also in coating. Again, if you come across these, you just need to know that QualiCoat members are always there to help. Yani. There's always a solution, and there's always a way to find it out. Again, you have third-party testing facilities. We have one here also, so you can get in touch and you can figure out the problem, of course. Last but not least, you might see different standards. Yani, مع الQualiCoat, you might see something called AMA, AAMA standard, which is an American standard. So QualiCoat is European, this is American, and they move sort of in parallel. So we said the higher the number, the higher the performance. So 1, 2, 3 QualiCoat is compliant to AMA 2603, AMA 2604, AMA 2605. So they flow together, they in sync together. And you might see them a lot in the same specification, okay? The advantages, just to sum it up so I don't read one by one in interest of time, okay? QualiCoat is more detailed. You have audits happening. AMA is a more generic specification. It's general. It has, and you say I comply to AMA and we're supposed to believe you basically, but no, you have to show us proof obviously. But no, it's more generic, you know. QualiCoat is very detailed. You always have auditing, you always have to have certified bodies, you know, and your chemicals tested. Here's a couple of projects from Al Taysir Group, AkzoNobel, Axalta, Gulf Extrusions. These are all QMEA members. Jotun powder coatings. And thank you very much. Sorry.
Thank you so much, Khaled. Expert on coatings. Please visit him at the QMEA booth to learn more. This was the last talk of this conference. However, last but not least, we have a very, very hot discussion, let's say, on a topic that affects everybody, I guess, everybody in this audience. And the topic is managing construction delays in the GCC. So I think construction delays is a natural occurrence in our projects. I think you can all agree. No? There's no delays here? All right. I hope that this discussion can bring some insights. We have some facade fabricators representing contractors. We have our moderator representing the client side, the architect side. So all voices will be heard. And more importantly, we would like to hear from you guys. So I have a microphone here, and I'll be passing it around. Maybe someone has an interjection, So please be brave and feel free to participate. I would like to call on stage our moderator and panelists, Mr. Mohammed Al-Khatib from Andalusia Group, Mr. Kevin Melli, Mr. Ibrahim Abdullah, please.
Hello, everybody. This is Mohammed Al-Khatib from Andalusia Group for Medical Services. And really, I'm really happy to be here in this brilliant event. And basically, we have a very serious case to speak about in this roundtable discussion.
Can I have this closer, please?
But first of all, I just want to ask a very simple and logical question. And I would appreciate if we take some contributions from good side audience. The question is, are we bound to do each and everything in our life in a hurry? Logic, right? In other words, I can rephrase it. Do we have to do each project, even in our personal life, in a very fast track, in a blink of an eye? We get it finished? Let's get it started. Sir, yes or no question? Okay. Yes or no? Yes, very good. Straightforward. Sir? No. It depends, right? Thank you. Sir? No. Must be? Very fast, right? I think you are investor, right? Yes. Elevation, what would you say? What would you like to say? Sir, let's participate. Yes or no? It depends. Thank you so much. From the flip side? Anyone? Yes. It depends on money, right? Thank you so much. So that's enough. I would say that it's a very controversial, and I do believe that it is utterly controversial. It depends. But what I would say that anything in our life, it must take time, right? But also, it has limitations. Nothing in our life has no limitation, right? So even our wedding day, our exams, our study duration has limits. So this leads us for the eternal question in this day: why projects get delayed? This is the biggest question here, and I do believe that brilliant people on the stage would have a very insightful ideas how to tackle this problem. But before taking this course of action for the roundtable discussion, I would say also to back to the audience just to give us some briefs about the delay causes, or who's the culprit that we can judge inside the project delay. Let's rise and shine, please. The plan, very good. Thank you so much. It's a very... The project management, thank you. Yeah, I think it is kind of one coin, two faces for the one coin. So, anything else? Multiple team. So you are talking about the people inside the project, right? Thank you so much. Anything else? Quality of people or the product? Thank you so much. Anything else? Thank you so much. So back to the point, and let's take a kind of roundtable discussion about what people have said across the project delay. One of those opinion that I'm totally respect, sir, he told us that the management would control over the delay. So how could we, enhance and improve such a plan to make it, to create an ambience that makes the project on schedule, not behind the schedule? Mr. Ibrahim.
First of all, I would like to thank Zak World of Façades for this brilliant opportunity to discuss such an important subject today. So let me be specific and talk about the facade construction, the delay in facade construction specifically.
Okay.
So here we're talking as an answer for the issue related to management. Yes, I agree 100%. A good management can prevent many delays factors.
Yes.
For example, the early selection for the facade contractor or facade specialist, and that's a management issue. The management of the project with such a decision of early selection of the facade specialist in matter of consultants and contractor will prevent design delay of the project, wrong selection of material for the project.
Yes.
So that's really an important aspect. Management also control budget. Management also control selection of proper facade consultant and facade contractor. So yeah, I agree. Proper management will lead to less delay or zero delay in any project.
Thank you so much. I would add something which is very important regarding the planning. I do believe that planning is wide range of experiences, and it's not about one discipline or one disciplinary, so to speak. It's all about 5 multidisciplinary people are working together. So we are talking about budget inside the plan. So we ought to do a cost management plan. So the budget at completion, how shall we do it, and the earned value across the lifetime of the project. So we have a plenty of information that you can glean from the Rohde plan. Thank you so much. Also, we have a great point regarding the
delays. Yeah, actually, from our side, what we're seeing on the projects on the building, it's going right back to the actual design stage, okay? Because the buildings are evolving so much, there's so many new details, new designs, new products coming into the building. What we have is the specifications of the project, okay? So the specifications, because the new designs, the new products, the new innovations on the facades, we're seeing that they're taking specifications from a previous building and applying them to a new building that they're working on. And it completely doesn't work. I mean, if you just take one item for like acoustics, if you want acoustics in one hotel, it maybe works fine. The next hotel you're building has all sliding doors, so the acoustic levels won't actually match the requirement of the building. So what happens is, from my time here in the Middle East, what I've seen throughout the project building, the specifications, they don't take really good care of them, They have them as a general specification, but they should look into them more and make sure all the points are valid for the project. So what happens then when we get to the end of the project and we're agreeing contracts and we're ready to order materials, then we have a conflict on the specifications.
I do believe that this conflict is really continued,
Yes.
As
And
much
it actually, it takes, there's so much delay in getting someone to confirm what's correct and what's needed for the project, and it increases the delay on the project right from the beginning.
Categorically, we are back to the point.
Yes.
So we have to plan it beforehand, before getting involved in.
It's most important that it's highlighted as one of the main points of any project, a good specification written.
Very good, very. Thank you so much for this insightful phrases across the planning, and how can we stitch it during the planning phase, and we can make some kind of splices for the project before taking the action of the execution, because it's very critical. So I just want to jump for the other point that we were speaking about before outside the hall. The budget. How can we tackle this problem? I do believe, I am from the owner side, and I do believe that we have a great problem in this, not only the budget, but also the cash flow So I need to finish, you know, a project of 10 million in 1 month, okay? And in the meantime, I don't want to pay it. I will schedule it over the last 1 year.
Okay, Mohammed, that's really sensitive. Okay, so I'm gonna be very frank, as most of you know me. So I'll speak clearly and I'll speak without any restrictions. Yeah, it's a big issue, the budget. It's a big issue, the concept of understanding the facade engineering. Unfortunately, there is a lack of knowledge in general. It started with the university degree. You need to do master's degree to know about facade engineering. Our colleague Osama Abbas knows this very well. We studied in big schools for the undergraduate. We never heard anything about facade engineering. So it starts there. Most of the engineers in their undergraduate studies, they don't know, they don't get any information about facade engineering. So it start at early stage. Unfortunately, we don't have this knowledge until we touch in our hands the aluminum profiles, the glass, the silicone, the protection tape,
Please,
all
Ibrahim,
these things.
I just want to address and point out a very important thing, apart from the educational phase or educational part. I do believe that budget can control over everything, right? Speaking about specification with Kevin is utterly useful, and we can use it, you know, to allocate the purposed budget before, you know, before the execution, before even the design implementation. So I just want to point out how budget can handle the project, you know. If the budget is decent for you, is that enough to finish the project on time?
Not enough, of course.
Okay, what are the other factors
The
that we
cash
can
flow.
take into consideration?
The cash flow, yeah, it's like it's twins. They are twins, the budget and the cash flow. So if you have the proper budget, if you do the proper study of your project ahead of time in matter of facade specifically, so you have the proper budget. Okay. Now let's move to the cash flow. We're still, as facade contractors, being considered from the main contractor as a main contractor. We don't have this luxury. We cannot afford the expenses of the project like the main contractor. We don't have the facilities for all our projects to act like a main contractor. So here the main contractor should coordinate with the subcontractor at early stage on how to finance the project in a proper way to prevent delay. So budget is not enough. Budget is very important, and here the knowledge leads to the proper budget for the facade engineering. However, the cash flow is as important as the budget.
Ah, very good, very decent. Of course.
Ignorance. Thank you so much. I was searching for you, by the way. You always disappear at the required moment. So what Brahim was trying to say is that there is a lot of ignorance in the industry.
Yeah.
Okay. Not only from you know the designer side maybe, or even you know at the level, even at the developer. Excuse me to say, the main contractor, subcontractor, suppliers. There's a supply chain of ignorance, and none of them understand how much time does it take to do things. Okay, vis-a-vis as well, you know, the quality that you need. You know, everybody needs a 10 million riyal job in one day, but nobody really understands that if you do this, you're going to lose the quality.
I don't know if I understood you. Please put me corrected if I misunderstand.
Don't worry.
You are talking about the ignorance, right? Ignorance?
No, ignorance. It's from my perspective, and I wanted to say this. Why are projects delayed? It's ignorance. Because when you tell your chef you want to cook mansaf in 1 minute, you're ignorant, and that's what's happening. Literally, you want them to do all these facades in very quick time, you know, under restricted budgets.
So it is not applicable, right?
Yeah. So what I'm trying to say is that ignorance is the major driver behind project being delayed.
Saying that I'm representing the owner side, and I do believe that And I have experienced it. I do believe that you have experienced a lot of things like that. People inside the investment ought to do each and everything to get their money back, right? So they will not allow you to take your time. Definitely, they will not allow you to do that. So you have to make amend. You have to find out ways out of this problem. Speaking about this problem in particular, I do believe that agile approach in the project management has a very, very viable product in this regard. So as a facade contractor or even consultant, you are talking about finishing the whole project in a certain time, right? But the agile methodology would give you a minimum viable product for the owner or the owner side. Why? In order to make him satisfied. That's it. Okay? So I do believe that everything must take its course, must take its time. But this is not be available with the investment sector, right? Okay, I'll move on. And let's talk about the communication inside the project. The lack of communication. Is that, come up with a kind of impact on the project timeline or
yeah,
delay?
of course. Yeah, lack of communication is one of the major reasons of delays. There are a lot of articles talking about this specific point, the lack of communication. Again and again, it's all in a small circle. The lack of knowledge leads to lack of communication. The late selection of the facade consultant and contractor is leading to lack of communication. So in any project, there are many parties. There is the client, the consultant, the designer before, then the consultant, you have the main contractor, and then have you the specialists.
Okay.
Let's talk about facade specifically, the facade contractor. Here,
is a part of
we have unfortunately, it's kind of habit or culture in our region that we select the facade contractor at the very late stage.
Yeah.
And that's very wrong. You should, whenever, select the main contractor, in like couple of months, select the facade contractor. We wait until, and you're talking, you know very well what I'm talking about. You're coming from a client background.
Right.
So yeah, so we select the main contractor. We stay until we do the concrete, to finish the concrete, to select the facade subcontractor. That's very late. There is a big period of time to finalize the design because, again, in many projects, we receive architectural drawings, not design drawings. So we, as facade contractors, are required to do the design drawings and the shop drawings, not only the shop drawings of the project. And this will lead to another kind of delay.
Yes.
So it started by the lack of communication, or delay in selection, the facade contractor, which is leading to all those kinds of delays.
Very impressive. Thank you so much. And I don't want to pass this kind of area of development until I take some kind of vote from audience. I do believe that, sir, how are you?
The beginning.
Yes.
Why? Because even though the structure, he should be at site from the beginning.
Of course.
To coordinate with the structure, and sometimes there are the client, he may change the architectural design, and may be reflected to the main design. So the design will be revised sometimes 2, 3, 4 times.
4 times, even unlimited.
Times for
Yes.
revisions.
Yeah.
So he should be aware. The subcontractor should be aware of the design review. Also, he should be aware of the structure, because sometimes some of the facade mechanism how to should be coordinate with the structure.
Yes.
So he should be there also for fixation, tariff fixation, and
Sir,
all these things. Mainly also electromechanical.
Yeah.
Some electromechanical, sometimes they are making opening here, and I mean some modification and it reflects to the facade execution also.
Very good, but
so I'm with you that we should be selective from the beginning.
Very good, but I just want to ask you a very critical question here, because I'm just trying to stick, to the point that I'm speaking about, the delay of the project. So, what if these changes came up after the execution beginning? Did someone experience something like that, guys? After the execution plan, after the execution phase, has become a factual thing, and the people inside the site are working hard to finish. The owner side gave a lot of changes. How can we deal with that? First of all, did someone experience something like that?
Yes, many projects.
All right.
Many projects.
Every project, yeah.
In the middle of the project, the client himself, he changed.
So how can we tackle it? This is the question we were discussing about.
Actually, it'd be good for this industry to have actual specialized companies that specialize in specifications only.
Yes.
For that reason, if you want to change any of the design, it's easy just to go to the specification company, tell them, give me the proper specifications for that.
Yes.
We can move forward with the project. If there's a design change, then no one wants to make the decision about what's the test requirement, what's the acoustics, what's the thermal. All these, no one wants to make the decision. And it creates so much delay on the project and to get started. By the time you get started, they want you to install the next day. They don't even have time to wait for the materials to be produced and ordered. They're trying to change then the materials that's available on the market. And all of a sudden, the project just becomes a mess.
I think you're very right. If you have some insights in this kind of in this point, Mr. Ibrahim.
Yeah, I believe I agree with what Kevin was saying. Yeah, it's a main issue that should be resolved at early stage. There are other things I'm keen to discuss, if you allow me. The poor scheduling is one of them. Let's be realistic. Yeah, everybody needs the project to be finished in one day. We all agree about this. But there is something very important also the client must know, that for us as facade contractors, as early as we finish, as much money we make at the end.
Of course, straight away.
So yeah, so in our field, mainly most of the losses in budget happens because of the delay of the project. Delays that comes through the things we are discussing and through also design changes that comes at late stages. Again, if we go back to the first point regarding the poor scheduling, the lack of communication, it's all connected together. I'm repeating myself, I know, but it is all connected. It is a fact, it's all connected together. Yeah, the early selection of the facade contractors will release many, will cancel many of those points.
Yeah.
Especially in case of design change, because that's the right of the client to change in design. It's the right of the contractor to ask for cost and time implication, of course, and us as facade subcontractors. So as early as we change the design, as much as we prevent the delays. So yeah, poor scheduling again, because of the lack of knowledge in our field, the facade engineering, the planners, the general planners of the projects. Of course, I'm not talking in general, I'm talking in specific cases, because we are really in much better situation nowadays, better than 20 years when we started with this field. So scheduling is very important. People must know how we do the work, how much we have suppliers in our end product, to know that scheduling must be flexible a little bit. Scheduling must respect and reflect the selection of material for the project. Like there are material that has a long lead time. It should be properly implemented in the schedule to not have a poor scheduling.
Very good, thank you so much. I forgot the point. Okay. We have just spoken. We have just spoken about the communication plan, and
Yes,
you gave very good insights. Thank you so much. But I just want to, to take some contributions also from audience about very important thing actually, and we took a sneak peek about it from the early beginning. The people inside the project, the team, the core team of the project. How could we motivate and give them the stimulus to achieve the tasks prior to or ahead of time? I do appreciate if we just make... Thank you so much for your support. They're very impressive.
Thank you. Yeah, it's funny that 1 month ago ASG had a session about this in Riyadh, and we were talking about how to enhance or deliver the 2030 vision projects with excellence. And a lot of these discussions are related to it. And one of the funny says that one of the guys says, 9 pregnant women will not make a baby in 1 month. And I think that's the main issue that we currently face. But it's fact, I think, to realize that Saudi is driving the construction industry globally, right? And we are in the busiest industry in the world. And we have accepted this challenge as consultants and contractors. And I believe it's on us to figure out the way how to deliver our commitments. But to me, I think it's the main issue is capacity and supply chain before anything else. A lot of people highlighted the project management and planning and stuff. And I think project management and planning is already being taken care of by the client based on their perspective, based on their goals, which is sometimes it's not realistic looking at the capacity issue that consultants and architects have, or the supply chain issue that contractors may face. And I think that's also make me ask the question of, do we really put attention to planning, project management processes, and believe that this is the outcome? And I think that's an issue we currently have in the industry. Clients, PMCs, even consultants, contractors, the moment that they put that process in place, they believe, oh, that's the outcome. And I think process is not an outcome, and we need to pay attention to that. And back to your question about motivation, I think everyone in the industry, speaking of consultants at least, speaking of us, we face a real challenge of capacity on our daily basis to deliver this work that we are committed to. And I think if we really want to motivate our teams, is to sort out the capacity issue, come up with enough resources, and find the competent people in the team.
Capacity, it's very good. But let's speak about the ways of motivation. If we have ways to motivate our team, I do believe all of those people are leaders in their careers, and they are leading a wide range of people inside and underneath the pace. The hierarchical skeleton or framework. What I'm trying to ask here, how could we motivate people? It's very simple. Okay.
It's very simple. I think we have to add first, because now we cannot manage the mega project like before 20 years or 30 years. Before we doesn't have IT, we doesn't have anything, so we can test the people, we can follow up with the people, we can even follow up with the function in the project. Actually, what's happening now in the market? I will repeat what did I say in the first. I say planning, because why we say planning? Planning, it's not a small word. It's the main key of successfully a project. When we say, now we are, as our experience as Dweck Factory, more than 14 years in the market on the aluminum field. We face a lot of a problem. What I say, planning, it's start from, not only from when you start building the project, when you start designing the project. Because they design, like engineers say before, a normal drawing, then when the contracting as a fabricator is coming to start working, he will suffer and he will face by this is not a compatible drawing. Yeah. So
you come back again as a designer to redesign the building from the first. So this is delay, and this is most pressure also to the team.
Yeah.
Then after that, you will go after that for selecting the material, blah, 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 blah. The people who's working on the project, if they are people, labor, or management level, or even owners,
yeah,
they will suffer from these things because you will stop. So you cannot say to the people, I need to finish it in a 1 month, and you doesn't have as an owner or as a consultant all the success key.
Yes.
From the first. So even we suffer big things. We need to be honest also. One of the things that some of the consulted on the market, they doesn't like and they doesn't need the project to finish because their job will finish. So I need to be honest. This is the fact. We cannot close our eyes. This is what we see. 20 years of my experience on the market, this is I see it daily. They doesn't need the project to finish. You finish it, they say, please, I need to change this from here to here because he need 1 month more for his contract. This is the problem, not only from the contracting, also from the consultant. The consultant field now, until now, there is no KPIs to control them. And this is one of the depression for the team who's working.
Yes.
You have good team, but you cannot let them work. Like you have a Ferrari car, but you doesn't have a road to drive it. It's the same. This is what's happening. So the people, you cannot send 100 labor, like he give a very nice example. 100 labor on the site, but they cannot start work because the design is stopped, because the consultant has stopped them. A lot of stop things.
Very right.
And even I say, as my experience, we have to add you cannot manage, like I say, the project by like a normal things. You have there must be KPIs there. You must insert the artificial intelligence on the management of the project from the first day until the end. So you can success. You can finish. We see some of the project in China. They finish hospital in a 3 month. This is not coming by the supply chain problem. Because in China, I have a flight.
I'm just going to interrupt here 2 minutes. The time for the panel is done.
Yeah,
really?
How about a closing remark?
Yeah.
I can't control it. I open it, but I can't close it.
We have to 2 minutes. Closing remarks.
Okay, in a word. I'm
Yes.
sorry. In a word, how can we tackle the project delay?
How many factories available locally here or of that standard, do they have that much of man and machinery in place to cater the project and to place the orders on time? This is my first question.
Thank you.
Do they have that liquidity in their place? Don't talk about the down payments. I'm talking their own budget. Is it in place for a project, for a certain project, at a proper time? This is my question, and I need answer from the industry.
Spectacular. Thank you so much. In a word, Mr. Ibrahim. Sorry. In a word. What is the key?
Shall I repeat?
Please repeat the question, yeah.
I know most of the fabricators here. I have worked with them from last 20 years. I know those factories. I have visited those factories. So when I'm putting a question, it is on the factual things. The thing is, do the factories do they have the men and machinery in place to cater a project of a large scale on time?
I'm sorry.
Second, do they have the liquidity? Do they have their own cash flow? Don't depend on the down payments. Do they have their own budget in place for a project? Well in advance.
Sir,
thank
sir,
you.
Just thank you so much for your. I'm sorry for interrupting you, but we are running out of time. So in a minute, in one word.
I don't believe that would really affect the projects because I mean in the UK we have companies that are running huge projects and they don't even have factories. That's all project management. I mean you can bring in a team, you can do a project, and these companies don't have.
Great
factories.
insight. In one word.
There's different ways around it. But what I do believe is gatherings like this where all the companies can come together, express their points, get a little bit of knowledge of all the different products in the one building. It helps the industry too much.
Okay, thank you.
Yeah, in few words, he was asking about two things, the capacity and the facilities or financial facilities, yeah. Regarding the capacity, I cannot speak on behalf of all the facade contractors, but for sure we can manage the capacity. That's the answer for your question. And regarding the financing, my answer now is no. We cannot finance the project. I'm being very honest. But here there should be a communication with all the parties responsible of this Vision 2030 or any kind of mega projects it's released in the market. It started with the clients, with the developers, then the banks to facilitate the life of all the contractors to finance the project, or to clearly understand that again the facade contractor is not a main contractor. We cannot afford the conditions of the main contractor. Exactly. So.
Okay, I do believe that we are finished. That the discussion was really hot, and I'm sorry. Thank you so much.
Thank you all for attending today's event. I hope you enjoyed it. As I mentioned this morning, we've recorded this event. We'll share the YouTube link with you a week from now, along with the feedback form. Until we see you next time around, thank you so much. I'd like to also thank my colleague Amro for hosting this event excellently, and looking forward to seeing you next time around. Can we have the Alumal team on stage, please? We'll do the mementos with the speakers, and also the speakers of this session, Osama, Abdullah, Rami, Ben, Khaled, or someone from QMEA. Did I miss anyone?
No.
No? Can we have you on stage? We'll finish the mementos.
Noorad Al-Gamouni,
Thank you so
please.
much. Looking forward to hosting you next time. Thank you.